Alrighty, everybody, let's get this started. So first thing I'll say, this will be a long class. The Google Calendar said this is going to be an hour. I told people it will be longer than an hour. They still put an hour. It will not be an hour. I'll just tell you now, the amount of time that we spent last night for the previous iteration of this class, 2.5 hours. It was a while. If you need to leave earlier than that, you are welcome to do so. All of the stuff will be recorded. But if you are around, then you can obviously ask more questions while I'm here. So the reason why this is a little bit longer is because there is a lot to do with CAD, and I want to try to give you guys as much of a kind of a deeper level like exposure to some of this stuff than like if I just show you, oh, here's how you make a square in CAD. Oh, yeah. No, I'm going to try to show you a little bit more useful stuff. So yeah, so if you guys don't know me already, my name is Ben Campbell. I'm a PhD student here, unfortunately. And so, yeah, I'll be teaching you guys how to do CAD, 3D modeling stuff, and be able to turn whatever ideas you have in your mind into some computer model, which then you can use to create something in the real world. So let's get started. So I'll introduce myself really quick. I'll introduce what CAD is. Then I'll get you kind of introduced to what Inventor is specifically. It's one kind of environment where we can do CAD design in. We'll get you started in that. And then most of your CAD work is going to be based on making sketches. And then those sketches you use to make features to then make parts. And then those parts you can then use to make assemblies. And then parts and assemblies you can use to make drawings. And then those files you can use to make various, you can do various imports and exports. So like, you're exporting a 3D model that you make into an STL file to get 3D printed, or a DXF file to send to a laser cutter, different stuff like that. So as I mentioned earlier, there is a lot, and coming out of this class, you will not be a professional in CAD, but I want to at least give you enough information to where you're no longer in a point where it's like, I don't even know what I don't know or something. I want to at least tell you guys what you guys need to know so that then, you know, as you're going out of here, you can find YouTube videos, you can look up internet tutorials one way or another, and you have at least a little bit more in your tool belt that you can kind of be, all right, I know how to navigate such and such problem in a little bit more efficient way than just starting completely from scratch, knowing absolutely nothing. So, yeah, just want to make sure that's clear at the start. So about myself, so I did a bachelor's degree in mechanical engineering at Northwest Nazarene University in Idaho. I can pretty much guarantee that nobody here even knows that that place exists or can point it out on a map, but I promise it does exist. There is more than just potatoes there. We also have onions. While I was there, I worked on multiple research projects. I worked on 5 different space missions that have now since all been delivered to space, 3 of them being satellites, 2 of them being sounding rocket experiments. And then from that experience, I ended up coming here. Originally, I was on a contract with NASA Marshall working on nuclear propulsion and having the government pay for school, which is awesome. Definitely recommend doing that if you can con the government into doing that. So now they are basically funding me through a PhD in aerospace systems engineering here, with a lot of my work having to do with spacecraft design. So I've worked on propulsion, payloads, basically the bottom of the rocket, top of the rocket, everything all in between. And so pretty much anything at this university that has gone to space in recent years or will be going to space in the next few years, I either oversaw or worked on it to some extent. Within the club, I am also the SHC Spaceflight Program Manager. I am the Terminus Project Manager, and then also one of the mentors for the RCS Challenge within 2 months. So who here has seen the Queens Gambit on Netflix? A few of you. Who here has at least heard of it and knows the general premise of it? All right, a little bit more people. So you know how it's kind of, you know, oh, this young protagonist kind of gets sucked into the world of like chess competitions and goes to Russia and does all this crazy stuff. So I did that except for CAD. It's a little geeky, but yeah, basically I literally have done like international CAD competitions. Like Vladimir Putin was there, even like I kid you not. Totally geeky, but yeah, CAD, I really like it. By one metric, depending on who you ask, I'm one of the best CAD people on the planet, unfortunately. So, yeah, and that is real. I did actually do this. I'm not just talking out of my butt. But that is a whole other story. So I've done CAD for well over a decade and very happy to teach you guys. Question? Autodesk Inventor. Yes. Go to just look up Autodesk student downloads and stuff, and I'll get into some of that a little bit later. But I sent out an announcement earlier to try to get people installed before the class starts, because I'll tell you now, it will not be done installing by the time this class is done, because it is a hefty boy to download on UAH Wi-Fi. It will take several hours. So yeah, yeah. So what is computer-aided design, or CAD? Basically, CAD is a very powerful tool that you can use to turn some concept that you have in your head into some model that you can pull up on a computer, you can send to anybody, and then also those people that you can send them to, or even yourself, you can use those models to then turn those things into real physical objects, whether you put them into a CNC, 3D printer, laser cutter, something like that. If you guys in the back want to go like steal a chair from next door and bring it in here, you're welcome to do that. That's all the chairs in the back there. That's where they were from last night. So like, for example, this is something that I worked on at the Propulsion Research Center. If you know, on the south end of campus, if you've ever heard anything that sounds like a loud explosion or gunshots or anything like that, promise this campus is safer than that. Like, any loud booms you might hear, it's from the Propulsion Center. We have a rocket test stand. We have various things that make fire and loud noises go on there. So, yeah, it's pretty cool. So CAD, there are a variety of different environments that you can use to generate these different models in. Some of you, is anybody here taking the Solid Edge class at all? Those of you, my condolences. I'll just say I absolutely hate Solid Edge. It's horrible. So I'll explain why in just a little bit. But these are some of the different platforms that are available. So like what we're going to be talking about tonight are Inventor, and then also AutoCAD is another very similar program, but specific to like 2D stuff. Some of that will be taught a little bit in the laser class that's in a couple of weeks. Question? What was that? What are your thoughts on SolidWorks? I like it. Basically, if I can't have Inventor, I have SolidWorks. If I can't have SolidWorks, I have Inventor. They're my top two. They each have different benefits, but I've worked with Inventor for a lot more. I've used Inventor since 2012, 2013, something like that. I was one of those nerds that like I remember the days back when I was doing CAD in like middle school for fun using like Google SketchUp. Does anybody even know what that is? A few people. Okay, so if you can imagine it like 10, 15 years ago, how much worse it probably was. I did that for fun at one point, unfortunately. But there's a bunch of different environments that you can use, and during 2 Month, you are free to use whatever program you want to use. Just make sure that your whole team agrees on one program so that you can exchange everything around. So I'm going to be teaching Inventor. If people want to use Solid Edge, they're free to use that. If you guys want to use like Onshape, SolidWorks, anything else that you guys have access to, you are free to use that. But tonight's stuff is just going to be Inventor. The reason why is, or I'll get into the reason why later. So the entirety of your experience with CAD will revolve primarily around the generation of some of these things right here. So sketches, this is where every CAD file starts at some point. So sketches, so these are, you're making some sort of a loop, or like you're making a rectangle, a circle, some weird outline of something. You're then going to use that sketch and manipulate it to make some sort of a feature. For example, you can make a sketch of like a square, and then you can apply like an extrude feature that brings it up and turns it into like a 3D box shape. There's a whole bunch of different features like that, one feature after another, you start generating parts. So that's where you start getting into all this different 3D geometry. And you can add features on top of features and features, and just adds on over time to where eventually you have something that is actually useful. Once you have a bunch of parts, you can start putting them together so you can make an assembly. So that's where it's like, all right, I have this block, and I have some screw that's going between and connecting them, something like that. Then you can also make drawings. Typically, this is something that if you have some design that you're sending off to some manufacturer to get made, so somebody that might have to go and make this thing manually. They go and they are at a mill and they're kind of running things along, making all of these cuts manually, drilling holes manually. They know exactly where all the measurements are, where all of those features need to get made. And then obviously with CAD, since this is a computer program basically, you can also export these to other formats. So things like 3D printing files, laser cutting files. You can put it into a CAM program for like CNC stuff. There's a bunch of different things that you can do with CAD. So now we're going to talk about Inventor. I love Inventor. So Inventor, in my experience, is the best program to learn for beginners. Is there anybody here that has worked with like Fusion 360 before? Okay, a few people. So if you know that well, this will be a breeze to transition to. Basically, just think of Inventor as Fusion's big, sexy older brother. So another thing that's nice, one thing I love about Autodesk is all of their products, all of their main ones, are free to students. So one thing, so Inventor, none of Autodesk stuff is on ChargeAware at all. I'm working on that right now, actually. Yeah, Inventor, it's very nice. Its user interface is very easy to navigate, very intuitive. There's also a lot more online like help and resources for Inventor as well compared to like Solid Edge, because you type in Solid Edge and Google's going to give you a bunch of results for SolidWorks all mixed in it, and it's hard to find actually useful stuff. Inventor, loads of things, and I'll talk about it later. There's one guy on YouTube that like has literally thousands of tutorial videos, and he actually has a personality. It's not some loser in his basement going, "Hello guys, today we're going to learn how to extrude a square." Oh, like no, this it's a funny guy from the UK. He's got a personality. He'll laugh at you if you say anything other than aluminium. Like he's a funny guy. So yeah, Inventor, I love it. So now one elephant in the room. So is anybody here not a freshman? Okay, like so those of you that are newer here, UAH teaches Solid Edge. I hate Solid Edge. Solid Edge is so clunky. It crashes all the time. It's hard to navigate. It is just a nightmare. I have never had a good experience working with this program. And the same can be said by a lot of other people, so much to the point to where even Siemens themselves, the company that makes Solid Edge, they don't even use it, but they sell it. So I hate it. UAH is also actively looking for other alternatives right now. So other things like on that other slide, like SolidWorks, Inventor, different programs. I'm actively lobbying for Autodesk stuff because it literally costs the university nothing to transition over. So yeah. Well, they still don't know what program they want to transition to, so they're still sticking with Solid Edge, at least for during this year. My bet is on Inventor. And even if they don't pick Inventor, then one thing that's nice is that it is very easy to start from Inventor, learn all the basics of CAD there, and then transition into another program that is laid out a little bit differently. Once you learn how all these basic tools work, it's when going to another program, it's basically just all the same tools, just organized a little bit differently for the most part. So once again, you are still free to use whatever CAD tools your team wants, just as long as everybody's in agreement of what they want to use. So hopefully, at least a majority of y'all already got it installed, hopefully. if you have not yet, on the 2-month Discord, I put an announcement out yesterday morning and then also one on Friday, trying to remind people to get this installed. If you haven't gotten installed yet, find that announcement and it's got a link there. You can also just Google Autodesk Student Education, or well, words. Autodesk Education and Student Access, or just like Autodesk Student Downloads. You'll find some page that looks like that one in the top right where it's some guy dying at a computer. But then below it, you'll have a whole bunch of programs. I'll kind of show what that web page looks like really quick. So this is what it looks like. I have an account made already. You'll want to make an account with your UAH email. If you do it with some personal thing like such and such name at gmail.com, it will not work and it's going to ask you for a load of money. Use your edu email, like your uah.edu email, and you get it for free. So make sure you make it with that, and it'll, like when you go and try to install something on this page, it'll ask you for like your school's details. So you put like the school's address, expected graduation date, things like, it doesn't have to be the exact date, just as long as it's kind of within the ballpark month and year of when you're trying to graduate, that'll be fine. And so there's a whole bunch of different programs here that you can use. All of these you can download as a student, use them, do whatever. And one thing that's cool about Autodesk is that these aren't all just a bunch of like discontinuous tools that don't talk to each other. Basically, every program talks to every other program here. So if you want to have some Inventor model talk with some video game thing that you're making in another program, like you can do that. So there's lots of things that you can explore around here. Very cool stuff. What we're going to be working with today is Inventor Professional right here. One other thing I would recommend installing at some point if you're wanting to do anything with like the laser cutting class later, I would also get AutoCAD installed. They work very, very similarly, but AutoCAD is more specific to like 2-dimensional stuff. Meanwhile, Inventor is a lot more for 3-dimensional stuff. Some people last night, they also asked about some stuff for like different types of like simulation stuff, like fluid dynamics stuff, stress analysis. If it isn't on Inventor Professional by default, there's already some other program on here that does, like, I have the CFD program somewhere on here. I'm not going to go through it, but like basically you name it, they have it. They're really cool. So let's see. Back to this. Let me make sure this is actually still recording. Okay, cool. Or wait, actually. Yeah, okay, still recording. Last night I had the mic cut out at one point, and there's a few minutes of like silence, so just making sure everything's still good. So yeah, make sure you do that. Go through, yeah, just follow those instructions. Everything is already on the Discord, at least this little set of slides right here. So now we're gonna get started. So for those of you that have Inventor installed, go ahead and get that started up right now if you don't already. When you open it, you should see something that looks like this. You probably won't see like these specific little pictures in the middle right here, but you'll have some sort of layout like this. If you have just a fresh install, chances are it'll probably be a light mode theme. Once everybody has some stuff open, I can show you how to do, I can set things to dark mode if you guys want. So let's see. While that's going on, I'm going to explain just a few good rules of thumb while that's loading. So these are some things that aren't always taught in CAD classes, but should be. So one thing that is critical, if you do this and you are working for me, I will fire you on the spot if you break some of these things, because that can lead to very big problems. So one of the first things, fully constrain all of your geometry. This means every line, every feature, every arc, every little anything. Everything needs to be properly defined. Basically, everything has some sort of a measurement to it, or you have some sort of constraint that's saying, hey, this line is perpendicular to this line, or you have some line tangent to some arc, stuff like that. General rule of thumb is if you can take something and still drag it and move it around, and it like changes the shape of something, you are missing some sort of a constraint. Add something to fix that. Ideally, if you go and try to drag anything around on your file and it doesn't try to move, then you've fully defined everything. The problem is that if you have some file like this, and say you accidentally drag something, or there's some kind of unknown, and then if somebody else tries to open it up and they don't know that something was dragged the wrong way or something, and then they send it over to some manufacturer for, you've got some fancy expensive CNC milling operation, and then you don't realize until you have 5,000 of the part and several hundreds of thousands of dollars in that, oh, we gave you the wrong file, we forgot to dimension this one part. That is a very bad day for you if you did that. So make sure you define everything properly. Also, make sure that all of your features are correct, easy to understand, and easy to modify later. You will never get anything right the first time. You're going to go back and make changes to these things. Make sure it is easy to navigate. Kind of think about it. Has anybody here done any amount of coding to some extent? Okay, so make sure your code is fairly organized, that you can navigate it easily. Kind of a similar deal like that. If you've ever heard of KISS, keep it simple, stupid. Keep it simple. So another thing, kind of similar to code, if you are ever repeating something, chances are you can likely optimize it using either some sort of a pattern or some other tool. Kind of like if you've ever had a good computer science or programming professor, they'll probably say something along these lines where it's like, all right, if you're having anything that's a repeated chunk of code, chances are you can do a loop or something. A lot less lines of code, and it's a lot easier to change properly. Kind of a similar idea like that. It's also sometimes helpful to break things into smaller, simpler components than one big, large, ugly thing. One example of this, at my undergrad, there was one team that was wanting to make a custom 3D printed drone. And the way that I discovered how they were making it was I walked into one of the labs and they were using the big fancy printer, and they decided to print the entire drone all in one part. And the way that they got it to fit in the printer was they had to print it at an angle, so then you have basically a cubic foot of support material underneath it to try to fit it at this weird angle. So then they took it out after hours of peeling away support material in all these ugly areas, and then they flew it for all of a few seconds, slammed into a wall, broke. And so rather than being able to do just a quick fix with a little strut that takes maybe 20 minutes to print, you're looking at another 2 days to print this entire abomination. Please don't do that. If I see you trying to print a cubic foot of anything, I will stop the print and tell you, hey, do better, please. So, also, pick one unit system. You can do freedom units, you can do communist units, you can do whatever you want to use. I will say I do kind of like communist units. Russia rubbed off a little bit on me, but the number 10 is great. But just find something your team likes and stick with it. Because if you're trying to have one person use metric stuff, and then you're trying to go to inches, there's always going to be some sort of discontinuity there, and it's just another headache that can be avoided. Another thing that's recommended is start with big general geometry and add finer details later. Kind of think of it like if you are drawing a person, or if you're not artsy, then imagine somebody else. Everybody here has seen a time lapse of somebody drawing a picture at some point. So when they're drawing, typically they don't start with, I'm just going to make this eye and then build everything around it. They start with, all right, here's the general form of the head, here's the general form of the torso, general form of the arms and everything, and then they go and just start adding details here and there. They add the eyes, the hair, all these different things later after they have a general shape of things. Similar rule applies to CAD, at least good CAD. There's also multiple ways to do things right, but also even more ways to do things wrong. With a lot of geometries, there's different ways to produce the same exact geometric output. It is all up to you. You can make, as long as the final output is the same, nobody cares. But if you're trying to do things kind of janky where you have one feature and then there's one part of that feature that you don't like, and so you take away some part like you're cutting away part of a corner or something weird. Then you add something back a little bit later. Like, just make the feature right the first time rather than adding basically a whole bunch of the equivalent of like duct tape and bandaging the thing together to get it back to the normal shape that you want. So make sure you just do it right the first time as best as you can. Another thing that will save you countless hours if you're doing CAD for any significant amount of time. For the most part, any kind of commercial part that you might be using, so for example, a Raspberry Pi, if it's some commercially available part that's fairly popular, chances are there is a 3D model of that already exists out on the internet. You can just download and import into your model instead. Like on a Raspberry Pi, do you want to sit there and model that little rectangular PCB and all the stupid little passive components that are mounted on top and the headers and the USB connectors? No, you will want to die. So just find it online, like literally just Google search whatever name 3D model, chances are it'll come up. So that'll save you a bunch of time. Final thing, one of the most important things, think of how this part that you're making and your assembly and everything, how all of this stuff will be made in the real world. Good rule of thumb, if you yourself can't conceptualize how this thing will be made in real life, you should probably improve it in one way or another. There's a lot of people that come in that are making CAD for things that are literally impossible to manufacture. Like, for example, you'll have somebody that is making some box and it's got like some weird undercut hole or something. It's like, it is impossible to actually fit a like drill bit or something inside to actually fit some weird hole or like go around some angle. Chances are, like, if you can't think of how this thing will be made in the real world, neither will anybody else. So, also, 3D printing will not solve all of your manufacturing troubles. It will solve some, but not all of them. For example, that 3D printed drone. It solves some things, but not all of them. So just some things to keep in mind. Take these, like, print them out, put them over your bed or something, recite them before you go to sleep, tattoo them on your forehead. Whatever way that you need to memorize some of these things, highly recommend doing it. These, like, if you can follow all of these things and do CAD effectively, you will be unstoppable. You will be the first person people ask to hire for anything mechanical ever. So CAD also, so how this is kind of done is most CAD, no matter what program you're using, typically it's done either in what's called an ordered or a synchronous mode. Ordered means everything is all kind of done in some sort of ordered fashion. There's a sequence to everything. If you look on the two pictures on the right, you can see there's this little, or here, I'll use the mouse. There's this little section right here. We're going to talk about this later. This is basically a browser. Think of this as this is all of the elements that define how this part is being designed. Right now, this part is fairly simple, at least compared to this bottom picture. So there's not as much geometry defined right here. But then as you go on here, you're adding more and more detail, and all of these features start accumulating over time, and this thing starts getting a little bit more developed. It's very nice. There's also synchronous mode. I hate synchronous mode. We are not even going to touch that. Basically, it's imagine having to do everything all at once. Ordered is way easier to learn as a beginner. Just, it'll be great. Also, so anytime that you make a new file, you'll be, actually, here, I'll just pull up Inventor for this, actually. So if you have Inventor, so I'll pull it up really quick. So if you open it up, it'll look like this. You can go up to the top left, and you'll just hit the new button. And then here you'll be greeted by this window right here. So now what this will have is, so you can, chances are you might have some things that you need to expand out a little bit, but everything is basically, there's a whole bunch of different template files that you can start with. So basically there's stuff for English units if you want to use that. So you can see everything here has like inches typically in the name. Metric has like millimeters and stuff in it. Starting with the English units, actually, is the next slide what I think it is? Yes. So these right here are the main types of files that we're going to be dealing with today. And pretty much all of the work that you do throughout 2 Month, and if you decide to do CAD after 2 Month, pretty much everything that you do for the most part will involve these kinds of files. There's a few others that you can use for like specifically like sheet metal manufacturing. There's different stuff for that, but for the most part, this is what you'll be dealing with. So everything is typically either a part, an assembly, or a drawing. And the way that they're kind of organized is, so you've got the types of units, but also there's different types of standards. These standards are used by like different countries and organizations. So like, for example, ANSI, I don't remember exactly what it stands for off the top of my head, but I know it's American something or other. And then you've also got, if you go to metric, you'll also see ISO or ISO. That is international something or other. Actually, that actually works. Let's just call it that for now. But that's the international thing. That's typically anything metric that's common. You're going to be using stuff for that. And if you start with any of these, they'll just the way that some of the tools are organized and how you naturally make certain features and things, they'll follow ISO standards for the most part. So like, for example, if you're using a hole tool later on, if it's asking you for some standard hole size, if you use like English stuff, it's going to ask you, all right, is this like a 1/4-20 thread hole or something like that? Or with metric, it's like, okay, is this like an M5 screw or, you know, whatever standard geometry, like something like that. We'll be, in this class, I'm just going to use millimeters. So we can have either a part like this. We've also got these different types of assembly things down here. You'll see there's mold design, there's welding stuff. We're just going to deal with just standard millimeter.iam. And then there's also drawing stuff down here. We'll also just use iso.idw. These are just basic drawing templates that have a few different things already kind of preset for us that we don't have to go and put in manually. So we'll deal with some of those in just a little bit. The navigation. So I am going to show you guys how to model some of this stuff. I'm just showing you general layouts of some things first. So actually here, I'm just going to make just something with standard millimeter.ipt. Yes, let's do that really quick. So if you want to go to dark mode, what you're going to want to do is you're going to want to go to Tools up here, and then it's going to get you this ribbon right here. Next, what you're going to want to do is you're going to see this little button right here that says Application Options. You're going to click that, and that'll bring up this window. It'll have a bunch of tabs up here, but what you're going to want to do is you're going to then want to go look for the Colors tab. Once you're in there, there's this little drop down right here for UI theme, and you can choose between light and dark right there. So I'll give some people a minute for that. It'll take a minute to transition everything over. Yes, so you're in the Tools section right here. So you go, there's these tabs up here. You go to Tools, and then you're going to go to Application Options. And then you'll go to Colors. So there's a bunch of tabs up here in this little pop-up that it brought. And then once you're in Colors, you're going to go to UI Theme down here. And then there's a little drop down with light and dark, whichever you want. So the general layout, pretty much all of your tools, kind of similar to like if you've used like any kind of like Microsoft Word or Excel tools, anything like that, all of your main tools are going to be in this top area up here. So this is where all of your main operations are going to be. One thing that might be new to you guys is this little thing on the left. This thing on the left is what we call a browser. So right now, it's basically empty because we have no parts here, no thoughts, head empty, just like me. But as we develop things later on, we can start getting a little bit more features involved. So, for example, this is one of the options of something that we can make in the class if you guys want. There's also, we can also make a traffic cone instead if you guys want. It's a little bit simpler. And so you can see there's these different features right here that you can kind of hover the mouse over them and they kind of show these different things that are like, hey, this little fillet right here, these are making these little curves kind of at the top and the bottom of the cone, different things like that. One other area, if you go over to the right, there will be some tools specifically for navigating around your part or changing your view. So the one thing that'll be your best friend is this little view cube in the top right. So with that, you can either click on a face and it'll kind of reorient your view around it. You can also go to any of the edges. You can go to corners. There's a handful of different things. If you also like hold, click, and drag, you can also just move the cube around however you want. So I'm just swirling it around with my finger really quick. Left click. So I'll go over that later. Or actually, here, let me just turn it off right now. Let's see. Let me just do that for right now. There's also, if you go to this little home button just above the cube, that'll just bring you to a default like kind of isometric view from like a top corner. You can redefine that later if you want, but like if you're ever in some weird ugly view, like you pan over to the side and you're like, oh no, where's my part at? Just hit the little home button and it'll bring you back safe. It'll rescale everything and bring you into a good view. So then you're back to where you need to be. So there's that. There's a handful of other tools over here. So like this little hand right here, this is the pan tool. So you can just click that and then you can just drag things side to side to kind of look, change your view. There's also this button right here. This is your orbit button. So you can click this and then use that to orient yourself around, kind of similar to how if you're dragging that little cube around in the top right. So those are some options, and there's some other tools in there, but those are the main important ones. I'm going to be using millimeters. You are free to use whatever you want though. And then up here, there's a whole bunch of different tools. So there is so much stupid stuff, and depending on what it is that you're doing, they all change and do different layouts also depending on what you're doing. So there are literally thousands and thousands of tools in this program, but I'm going to be showing you a lot of the basic core functions that are used for just about everything. So that's kind of a general layout of things. One thing also, is anybody here, like, has anybody here never used Microsoft Excel before? Okay, good. So you know how in Excel you can have like cells and functions and things where it's like you reference some other cell, it does some math, spits out some number at the end. You can do that exact same thing with CAD. If you do your parameters and equations right, you can literally change one little variable and have some big ugly assembly of like a car engine and change it from like a 4-cylinder to a 6-cylinder. And it changes all of the everything if you do it right. So if you learn how to use this stuff right, it can save you a lot of time if you're trying to do like very rapid changes for things that can be somewhat drastic. And the way that this is set up, so you'll have a window that looks something like this, and I'll show you how to access it in a second. Basically, you'll have something that is all of the names of every possible dimension. Any kind of way that you can define a number in your model, it's all mentioned somewhere in here. And then each one of those is also, it shows where that dimension or measurement is being used, what type of units it is, whether it's like length or an angle or unitless or something. And then you've got some sort of a number, or you can also put in an equation where it's like, hey, this right here, I want this to be like D0, like this, whatever like dimension 0 is. It's the equivalent of like the location of the cell. So like cell A1, for example. I want A1 times 2 does something, and then it changes something. So the way that you could access something like this, so if I go to like this empty part, If I go to the top right here, there's this little like f of x button right here. If I click that, it'll bring up this little window, and right now it's completely empty because the part has no geometry. But if I go over to like the traffic cone, for example, and I go and hit that, now there's a little bit more here, and you can see there's some stuff where I already put in some math a little bit earlier. So here, like I've got D21 minus D24 divided by 2. So that's where I'm taking wherever, yeah, I've got D21 and D22 over here that I'm referencing in here, doing some math with it and doing things. Here I've got D32 doing something else. You can have this and set it up however you want. I would recommend at least looking at it from time to time. A lot of people by default, they don't even know that this exists. But if you know about it and know how to use it, it will save you hours and days of time, especially when going through and changing things. And there's other ways to do these kind of math operations automatically also. So now we're just about at the point where we're going to start making stuff. So a lot of CAD and technical drafting classes, when you take them when you're taking them and you're in the very early part of the class, they're going to give you very basic, kind of useless stuff to make. So like these are some examples of some things that I've seen in other classes, and like you're looking at them, it's like, these are useless. I will never look at these designs ever again after I'm done making them and submitted them for my homework. I want to do something else. I want to do something a little bit more interesting. So one option that we can do, we can make a lightsaber. We can have something, it's like something that's at least a little bit more interesting than a useless block. So this is an option of something that we can do that basically all of y'all can, everybody suggests a design and we make it in real time. Something that I haven't made before, something that you haven't made before, we work through how to do it together. That is one option of something that we can do. So we can take like some existing picture of a simple lightsaber design from like the internet, and then we can make our own version of it. So if you wanted to make your own lightsaber with Girl Boss Baby and Comic Sans on the side of it, we could do that if you guys want. I will say we started this last night with the first class and we didn't finish it, and it did take about 2.5 hours. So if you guys want to go a shorter route that isn't as in-depth, actually that's the design that they picked out and we were using to... We mainly just did this middle handle part right here. But another option that we can do, if the lightsaber option seems a bit too ambitious, we can do a traffic cone. There's different ways to make this, but it's not as interesting as a lightsaber. So we can do this, or if anybody has any recommendations of any other thing that is easy to make within the span of like an hour or two in CAD, we can do that instead. So does anybody have any preference on doing the traffic cone? Raise your hand. Right. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is voting for the traffic cone. So I counted, those of you with the traffic cone, put your hand up. Okay. All right, and then lightsaber. Sad. Okay, well, it looks like we're doing the traffic cone. So one thing I will mention is if you want to look at lightsaber stuff, the model for this Girl Boss Baby lightsaber that I made, the files for that, if you go to the Canvas page, there's a folder that is in here. It's called Intro to CAD Demo Models. That lightsaber, all of the files for it are right there that you can download and look at those things right now if you wanted, or look at them later. The traffic cone, which we'll do today, all of the files for that are here as well, but we're going to walk through how to actually make all of those today. So we've got traffic cone right here. So we go back to the slides. So the way that we can make this, there's a handful of different ways that we can make this cone. These are some of the different tools that we might be using, some of the different features. You don't have to use all of them. We probably won't use absolutely all of them. And there's more than one way to make this. If there is some way that you feel you want to try to make it yourself, you can do that. But I probably won't be answering questions about things deviating from whatever it is I'm teaching everybody else, just to make sure that I'm trying to help the most amount of people at once. So yeah, the rough dimensions for things, if you want to look at this drawing and try to make it yourself, the file for that, if you just go to SHC traffic cone in the canvas page and just open that up, that's where this file is. So you can look at that if you want to have that like in another tab and just use that as a reference if you want. So does anybody have any questions so far before moving forward with starting to actually make this thing? See, chances are it will not be done. Like, when did you start installing it?
When we started the class.
It will not be done. It just won't be done. And then you had something?
So I'm aware there's something you can do to fix this, but I have a Mac and I can't get Inventor, and I've used Inventor before. Is it possible to I'm trying to maybe follow along with AutoCAD? Is that going to be possible at all?
You can do some sketching, so if you have AutoCAD installed, most of the sketch tools are pretty much the same. Do you have a virtual machine on your computer at all? Like, they can run Windows. So if you can't get one running on your computer at some point, one thing that is also an option, because somebody at the class last night had a similar issue, I do know that the library rents out like Windows laptops to people during the school year for free, I think, actually. So like it's not the latest and greatest thing, but it is a Windows machine that can run CAD. So sometime this week you might be able to go get one. Not as many people know about it, so if you go and get one before they're all gone for the year, I would go and at least check it out. So if you, yep.
Okay, got it.
So, yep.
When you make a new model, how do you name it? Where is it stored? So when I open up AutoCAD again, or when I open up Inventor again, where can I go to find it?
Yeah, so you can choose where all that is. So here I'll show how to do that here really quick. So so this right now we just have this like part one thing. It's just an empty something or other. It's these it's nothing. So what I'm going to do is I'm going to go to the top left and hit File. And I'm going to hit Save As. And then you can pick wherever it is that you want to save it at. So I'm just going to go find thing. I'm going to make a new folder really quick. Class 2 files. I'm just going to call this traffic cone demo. I'm just going to call it that. So then now, if you go to that directory, oh, that is very deep in things. Let's go so we can find it. Class 2. So then that is where that file is now, just wherever it is that you wanted to save it.
Okay.
So right now it's empty. It's got nothing, just like my head. So next, does anybody have any other last questions before we move forward? All right. So what we're going to do, we're going to start off with a sketch. So what I'm going to do is really quick, I'm just going to introduce some of these different tools and things, and then we'll walk through actually doing it. So make sure that this is still recording. Okay, awesome. So at the start of any part that you ever make, you will have a sketch. Basically, that sketch, you'll use it to make some sort of a loop. Basically, you need some sort of enclosed shape to do anything with it. So that can be either you can make a circle, you can make a rectangle, you can make any kind of sequence of lines and curves to make at least something to start your shape with. What we're probably going to do with the stuff tonight is we're going to start off with like, you know, that kind of square part at the bottom of the traffic cone. That'll be probably the first sketch that we do. So you'll make some sort of loop like that, and then you can eventually turn that into a solid with some sort of a feature. By default, like when the part is completely empty, you're going to have this little button in the top left called Start 2D Sketch, and that's located just up right here. Make sure you're in the little 3D model tab with all the different tabs up here. So you would end up hitting that, and then you'll see this kind of, you basically have your basic coordinate planes. So you've got like your XZ face, YZ, XY. You're just basic directions, X, Y, Z. So they're all there. And what you would do is you would eventually pick one of those to start with, and then it's like what I'll do. So it's asking me to pick a plane to start a sketch on. I'm going to pick this one that's kind of in the equator area. It's this flat one. So I'll pick that, and then it orients my view looking down, and then now you'll see the toolbar up here is now changed. If we go to the next slide, you'll see a set of tools that looks something like this. So these are all the things you'll do, or all the things you'll use to make sketches. Anything that you are using to generate new geometry is going to be these tools all right here. So for example, the most basic one is a line. 2 points, connect them, easy. You also have like circles, you've got arcs, you've got rectangles, all these different things. There's most of these, they also have some sort of a drop down menu also that has different options. So you can look at, like for example, on the line section, if you hit that little drop down, there should be like a little option that's like if you want to make some sort of a spline curve, some weird fancy thing. With circles, you can drop down. You can also make like ellipses and things. With rectangles, you know, you can do all these different things. You've also got this project geometry tool, which I'll talk about a little bit later. You also have these modify tools right here. These are, if you want to modify things, pretty self-explanatory. So you can either have, like you can move certain things, you can copy, rotate, all these different tools. One thing, if you don't know already, the offset tool is very, very nice. If you have some outline of something and you want to kind of add some kind of bubble around it, some sort of, like let's say you have some obscure shape and you want to add some additional boundary to the end of it that is some uniform width going all the way around, you use the offset. You then pick some line or a set of lines, and then you just choose some distance that you want it to offset off kind of outside or inside a certain way. You also have these pattern tools right here. So you can make either like rectangular patterns, so like kind of like a grid. You can do like a circular pattern, you know, circular, or you can also mirror apart. So like if you wanted, you could try to do some sort of a CAD model of like half of somebody's head and then just mirror the other side, and then now you have a full head, something kind of like that. So this project geometry tool, this will be very, very helpful, and I'll show how to do it a little bit later. Oftentimes what I see people doing when they're new to CAD is they are making, you know, you make some feature and then you're making another sketch, you're trying to do something else. A lot of times you need to know where some of the geometry is for these other features. For example, let's say you have some sort of like square plate and you're trying to have these little like drilled holes in the corners. If you have, let's say, like a 4x4 inch square, and then you want those holes to be like a 1/4 inch away from the edges, something like that. But then if you end up changing the size of that square to say like 5 inches or something, now those circles are no longer in the corners. They don't move with the boundary if you don't reference it. This project geometry tool, what that lets you do is that lets you reference other existing geometry, and you can make dimensions and constraints with new geometry to it so that when you go and update something else later on, it'll update the sketch in real time, and then it'll move whatever other geometry you have connected to it and modify whatever features come from that. And it's this kind of chain reaction to where you can, if you do it right, it makes modifying parts much, much easier. Also, say you're trying to repeat some set of geometry, but rather than going and like, say it's some ugly, complicated loop of things. Say it's like some ugly star and you don't want to go and redraw every single line. You can just use the project geometry tool and just say, hey, just pick that feature, copy all the outlines from it, and then bam, you have all those lines drawn without needing to go and redraw them all manually, something like that. We'll use that very frequently. And then also, dimensions and constraints. These, you need to use them. So this dimension tool right here, you can use this to basically click on certain lines and apply some sort of a measurement to it, whether it's like a length, some angle, something like that. And then all of these other tools right here on the side, these can be things like, all right, I want these, like, so this one right here, it looks like two lines that are parallel to each other. What do you think it does? Makes lines parallel. So you pick one line, you pick another line, you use that tool, bam, now they're parallel. You can do similar things where it's like, if I want like circles to be concentric, if I want lines to be perpendicular, I want something to be tangent, one thing or another. This little lock button right here, if there's some sort of constraint that you don't know how to use it, or like you're trying to lock your geometry in some way, but you don't know which proper constraint to use, you can use that, just that little lock tool. But general rule of thumb, any good CAD, you should know what kinds of constraints are needed, and you should be able to use one of these other tools. If you find yourself in the position of needing to use this little lock tool, you can probably do something a little bit better. And then, you go through, you make all these lines, you make some pretty picture, and then eventually at the end, you'll hit Finish Sketch. And then what that'll do is that'll bring you out of this 2D sketching mode and bring you to 3D mode, which then you can actually make some feature with. So now that we kind of know what these different tools are, at least what they're called a little bit, let's actually use them now. So we're here, we made a sketch. And for those of you if you missed the like make a new sketch part, I'm just back to this normal like empty nothing part. I'm going to go up to the top left and hit start a new 2D sketch. So I'm going to click that, and then there's going to be these 3 different planes right here. To make this traffic cone, I'm going to start at the bottom and kind of make that little square part at the very bottom. So I'm going to choose this kind of flat plane right here. So now we're here, and you can see this little view cube right here. Now we're looking from the top down. So what I want to do is I want to basically make some sort of a square or a rectangle. So, question? Let's see. Hit that. Also, have you restarted your computer since installing the computer, or since installing Inventor?
Yes.
Okay. Here, can I see this real quick? Or you're in assembly. You're in the wrong type of file. You need to go do one of these instead. So we do that. Start a new thing. So then there you go. Okay. So yeah, make sure you're in. Let's see. So one thing really quick, if I go here, make sure you're using like standard.ipt. Make sure it's something in this part section right here, not in assembly or any of these other files. What we're doing right now, we're just doing a simple part. Just make sure you do that first. So once you're here, you're starting to make a sketch. So there's a few different ways that we can make a rectangle or a square. We can use lines if we want. We can just click that line tool, and that's, now we have a little cursor here, and it's asking us to pick these dots out, and I can just kind of draw lines however I can make something. I can do whatever kind of ugly thing I want to do. I'm going to undo all that really quick. And so as I'm making any kind of line or feature, you'll see these different text boxes show up. So you can see there's one that's looking at kind of the length of this thing. So you can see the one that's like around 26 millimeters right now. And then there's also, if I hit the tab button, I can now flip to this degree measurement right here, which right now says 180 degrees, but I can flip this around and say whatever angle I want. So what those are is when I have one of these highlighted, it'll highlight one of them by default. If I want, I can just type in a number. So let's say I want 40 or something. And then I can just hit enter. And then now I have a 40 millimeter long line. I can do something like that. Or what I also could do, I could just do some line that's just whatever, and I just click. Now I have this line, it's green. Typically, any line that you see as green, that means it's not fully constrained yet. There's still, you know, you can see I can drag it around. It's not defined. There's no measurements to it yet. If I want to add some dimension to change the length later, I can use this dimension tool up here. So I can just pick that, and it's a really smart tool that you can just kind of click that tool, and you start picking parts, and it'll kind of just identify what it is that you're trying to do. It's not like you say, oh, I want a linear dimension or an angular dimension. I want whatever. Like, it'll just kind of know. And for the most part, it's right. So it's pretty good. So right now we have that dimension tool selected. And now I'm just going to click this line. It's going to bring over kind of this little note thing on the side. And right now you can see it says like 47.488 right now. And so if I click on it again, now what it does is that it brings up a little window where it's asking to put in a number. And I can change it to something else if I want. I can hit that. And then now it has changed the size of that line. I can also go back and just double click that, and I can type in another number and it changes it. I can do whatever kind of thing I want. One thing that you can also do, don't get in the habit of this, but it is an option if you need it. So you can see right now this thing is in millimeters. If I just type in some number, since this is a file that's got default units in millimeters, I can just type in a number and then hit enter, and it'll autofill in millimeters into the dimension. It is also possible to use other units. So say, for example, I wanted to use inches. If I wanted that, I would just replace the units, so that millimeters with inches, and then hit enter. Then now it's going to be like huge, but that is now 40 inches. I'm going to hit undo on that, but you can do that. You can also do math in here. So very similar to how you can just type in functions in Excel, you can also do functions in here. And these same functions right here, so you can see this dimension is labeled D0. That'll eventually show up in that little parameters thing. Right now, it's already there. It's set as 40 right now, but I can do the math in here, and it'll update between here and here. They're both the exact same thing. Basically, it's like looking at an Excel cell in two different areas, basically. So let's say I wanted, instead of 40, I wanted, let's say, 10 plus 30 or something like that. So now that equation updates to be 10 plus 30 millimeters. I can hit done. I can go to here, and now that equation is in here. Let's say I wanted, if I wanted to make this a perfect square, so I can kind of bring this over. And one thing I'll also mention is if you're drawing lines, oftentimes if you're trying to go to some basic direction, so like completely horizontal or like completely vertical, it'll often kind of snap to that. If you want something at an angle, you can do that too, but it'll be good to define it later. Oftentimes if you do something in some direction, and so you can see it's trying to kind of snap to horizontal mode. And you can kind of see, if I move my mouse, it won't do it, but you can kind of see there's this little thing that's popping up right here. So that is basically a sign saying, hey, I think you're trying to make some constraint. That's what Inventor is thinking. So it's thinking, hey, this line looks like it needs to say horizontal. Let's just add a horizontal constraint to it. So then now you can see if I click on it, there's this little button right here that now if I try to drag it, it's not going to bend around or anything. It's going to stay flat. So something like that. So I can take this, I can drag this line. However, I can still change the length. I can move it up and down, but it's not changing the angle. And then same deal with this. So it recognized, actually my view is rotated weird. So that's a horizontal constraint, and that is a vertical constraint. So I can move this stuff around, but I can't change the angles because now there's constraints. If I wanted, I could take this constraint, right-click it, and then hit delete. And then now if I wanted, now I can make this all loosey-goosey and angle stuff because that vertical constraint is no longer there. But I want that, so I'm just going to hit Control Z a couple times until that's back. So now we're here, and let's say we want to start making this into an actual square, something useful. So if we go over to dimension, we can add a dimension to this line and give it a length. Now, it is also possible to just, type in 40 or whatever, or actually, let's see what the dimensions say on this one file. Let's see. This is 500. Okay. So I'm going to make this 500, and this is going to be 500. And now we've got these lines right here, and we can still move it around. So there's still some measurements, but we're gonna add some other measurements later. So let's say, or let's complete this square really quick. Let's bring this around. Let's make this 500. Then we'll make another line. We can go and it'll actually kind of just snap to this line right here, and it'll make a connection there. So then if I move this line, now I have a square. Now let's say I wanted to change the size of this. So if I went and hit on this, let's say I wanted 200 instead. Now I would have to go through and modify each of these to be 200. That takes time. One way that you can do that change a little bit quicker is if you have everything all referencing one basic dimension, so that you only have to change one number, and then it updates all the rest, similar to Excel functions. So what I'm going to do is I'm going to use this right here, this D0 right here, as my dimension that I'm going to use to drive a few other things. Question?
How do you deselect the dimension tool?
You can just hit the escape button, and it should bring it out. So this D0 right here, we're going to use that. Now, we're going to use that number and basically say, I want this dimension to equal this, and I want this dimension to equal that, and I'm also going to add a dimension for this fourth line over here. Or actually, I'm going to ignore that because all the others are defined. So what I can do, if I wanted, I could just type in D0 and then hit enter. Now you can see there's this little like f of x colon 200. It's meaning there's some sort of a function here, and whatever that function is, it's spitting out 200. So now if I go and change this right here, I can then change this to, let's say, bring it back to 500. I'm going to type in 500, hit enter. So then now you can see it's changed this line. So it updates in real time. I'm now going to do the same thing here, but I don't have to just type in D0. I don't want to have to go and look up every single dimension because, as some of these parts get a lot more complex, you're going to have a lot of things. And it's like, oh, did I use D147? Oh, no. One way that you can do it that's a lot easier, similar to Excel, how you can just kind of click a certain cell to reference it, you can just click a dimension instead. So here I've got the text box is empty. I'm just going to click that dimension, and now you can see it just populated it with that dimension. Then I'll just hit enter, and then now that's updated. So then now I can change this. Let's say I want to go to 350. Hit enter. Now it changes everything. Everything is all able to be modified a lot quicker. One thing you can also see, we're not quite centered with kind of the origin of this drawing. You don't always have to be, but it is good practice to stay somewhat, reasonably positioned around your origin in some logical way. So one way that we can center this, we can use some additional dimensions where we dimension some of these lines in reference to this center point right here, the origin. It is possible to kind of drag these a little bit and kind of eyeball it, but it isn't quite exact. You're always going to be at least some amount off. One way that you can do it exactly, you can add a dimension, and now we're going to add, we're going to click like this line. And right now by default it's saying, all right, we're trying to add another length right here. But if I go and click another thing, so like this dot, now it's got a new length dimension right here. So if we have this, it is possible to do like I mentioned before, we can just type in a number here, and that'll be fine. But what we can also do, we can do math. So I can clear this out, and then I'm going to pick like this width right here, and I'm going to hit divided by 2. So I'm just typing that in. So just D0 divided by 2, and I can hit the check mark. So then now, if I update this number, so let's say bring it to 300, it'll then also change that middle dimension that we just added so that it keeps everything centered. Bam. So horizontally we're centered, but not quite vertically yet. So, question?
How can you change, like, how are you changing one side's dimension without?
So that's with referencing it in other dimensions. So if I type in a thing here, I can either type in the name of the dimension that I want right here, or I can also just, in the little text box, I can just click the other dimension I want to reference, and it'll just auto-populate that number in. So then I'll just hit the checkbox, and then, yeah. So, yes? Yeah, like, do you have the dimensions in the middle? No. Or it's stuck away from the middle. Let's see what you got. So, you can move it. Oh. So you have to click and you have to hold, click, and then drag.
Okay.
So that's all you got to do.
Like...
So, let's see. Let's make sure OBS is still recording. Okay, cool. I'm gonna bring that up just a bit. All right. So we've horizontally kind of centered this thing. So you just click a line, and then you just hold the click and then drag. So you just hold left. Let's see. Just hold left click and then drag, and it should be able to just move around freely. Let's see. So, so you already have dimensions there, so it shouldn't move.
But if I wanted to move it,
then you'll need to delete the dimensions that are locking it. So if you delete those middle ones,
can I delete that by?
Yeah, so you can just select it and use the delete button.
Yeah.
Let's see, or let's see. Here, hit the X really quick. Let's escape out and just click on it, and then hit delete. Yeah.
Okay. Was I in?
Yeah, I think you were like some edit mode or something. Let's see. I think if you changed,
Yeah, I don't know why it doesn't.
It's the way that you're highlighting is changed. If you go to, did you change any of the other settings with changing things to dark mode?
No.
Okay. So one other.
I don't think so. I have no idea what I'm doing.
So yeah, because the way that your UI is set up is different than what I have there. Let me try one thing really quick. Colors. Yeah. So by default, let's see. Because what it does is that it also changes the way that like the colors are, or like the way that the lines are colored. So now that's a little bit easier to tell when it's selected. Meanwhile, before it was like 2 very close shades of green.
Okay.
So you should be able to just click that and then delete it. And then from there, you should be able to then start moving stuff. So when those measurements are there, it's locking it and saying this line is only ever this far away. So, yeah. So if I wanted to center this thing vertically, does anybody have an idea on one way that I could do that? So if I make a dimension, so what is the next thing that I should click? Or one of the next things? All right, so I'll go with the top one. And what should I click next? Yep. And then click here. What should I do now? What was that? Yep. So I can do that, divided by 2. Magic. So now we have a square. Yay! So, yeah. So there's that. And then now, one thing that y'all are going to love, I'm going to delete everything.
How do you delete everything?
You can just make sure you don't delete the origin. It is possible to delete it. So make sure you don't delete it. So like you can just click and drag and it makes a little window. So you can delete things. One quicker way that you can do, you can just go and make a rectangle. So there's a bunch of different options here. I'm going to use one common rectangle that I use a lot is this 2-point center right here. So how this works is you can basically select the center of a rectangle, and then you can pick another point that is your corner. So here it's asking me for the center. I'm just going to pick my origin. Then now I can just go out here, and then now I can just type in some number I want. So let's say 500, then I'm going to hit tab, and then I'm going to hit 500 again, hit enter. Now we've done the same thing, but a little bit quicker. So there's some different options here. I can also go and take this and rename it that. So then if I change this to say 400, it's there, and the center is already defined and everything. So I have a little bit less dimensions, a little less numbers I have to worry about. So there's that. If I wanted to move or copy or offset anything, like so for example, if I wanted to offset this, I could have this square or this loop, I could select it and then I can bring in something a certain distance away to make another square if I wanted. Then I can just go and add some dimension, for example, make something else. I'm just playing with tools. This isn't part of the actual part, but there's a handful of different things here. And we're going to use some more of these tools a little bit later. So now that we have this basic square part that's going to be the bottom of our traffic cone, we can just go and hit Finish Sketch at the end. And then we can kind of zoom out. Now we have this basic square. Are there any questions up to this point? Yes. The X thing. Yes. All right. So I'll do that again. So. Yeah. So it's a tool. So if I'm. So. Yeah. So if you hit the little drop down with the rectangle, you'll see some different options. So I used that rectangle tool that's a 2-point center. So that's asking me, basically, if I look at this little graphic right here, one thing I'll say that's very nice about Inventor, just about any tool that you use, if you hover your mouse over it, it will give you a little pop-up like preview of what the heck the tool actually is, how it gets used. So you can just click that and you can see here, I've got 1 point in the middle, like number 1, then I add a second point later, number 2, and I make the thing. So I'm going to use that and then just kind of drag and then type in my numbers and then so then I've got that. Question? Let's see. Or okay, yeah. If you guys are able to help him, that okay, awesome. Question?
My Inventor looks a little funny. I think I did something wrong.
Oh, that's
Joshing.
okay, yeah.
Sorry, joshing. I was actually wondering if I could give code.
What was that?
I was wondering if I could give code because that's a code.
The
I don't think. I mean, Not that I don't find code or CADing really fun and exhilarating. I just would like to go to better.
Yeah, like if you know how to do CAD already, you can head out if that's what you're wondering. Like this is for like people that have never touched CAD before ever, or if they're wanting to learn Inventor, they can do that. But yeah, okay, that's good. All right. All right. So one thing I'll mention, everybody, there is more than one way to make a square. If you want to go and just make 4 lines, you can do that. If you want to use this little rectangle tool, you can do that too. Any way that you want to make 4 lines, as long as they are dimensioned properly and like perpendicular to each other all the way around and centered, as long as you can do that, you're just fine. So there's plenty of ways to do that. So like there's the first option we did earlier with just adding measurements around for everything, or this rectangle tool. Is everybody good if I move forward past this rectangle?
I just got it downloaded. So I'm trying to think, I've got it open and now I'm trying to figure out.
I would say ask a neighbor. So I don't want to hold the rest of the class back. All right. All right, now that we have a square, we're going to move forward. So I'm going to hit Finish Sketch. We're going to come out, and then now we have this kind of flat area that right now it's nothing. Next, what we're going to do, we're going to start dealing with the different ways to make this into 3D and start actually turning it into something real. So when you exit out of that 2D mode, you hit that little Finish Sketch button in the top right. You'll be brought back to 3D mode, and you're going to see a bunch of tools at the top like this. So for right now, what I have this exact same toolbar up here after I hit Finish Sketch. So we're here, and most of your tools to make anything from the geometry that you made is going to be these right here. So, question?
My square is in the wrong dimension. It's upright. It's not.
I would say ask a neighbor. So, all right. So, so most of the tools that you'll need are going to be here. This little one right here called Extrude, and this one little right here called Revolve. Those are probably going to be the 2 most common features that you use for pretty much everything. And then everything else are all kind of little details or other ways you can make solids out of things. So the way that Extrude works, you can kind of tell by how the icon is set up, where you have basically something and you have some profile and you're extruding it in one direction a certain amount. Revolve, you can also tell by the graphic, you have some sort of profile and you're revolving it around, making some kind of like curved or arced solid. There's a handful of other tools here. We won't deal with all of them. We'll deal with some of them. So there's also like the sweep tool right here. This is where you can basically have some sort of profile. You have it follow along some path that you give. One example of how this could be used is you could have some sort of a circular profile that then gets kind of swept along some path in the shape of a paperclip. That's how you could 3D model a paperclip. There's also this loft tool right here. I won't go too much into it right now, but we will be using it later for part of this cone project. There's also the coil tool. If you wanted to make like a spring or something, some sort of a helix shape, you can make some sort of profile and bring it around something where you can define the pitch, the turn radius, all of that stuff. There's also the emboss tool. If you wanted some shape or even some text kind of projected onto some like ugly curved surface, so like say you wanted to put like girl boss baby on like the globe or something, some sphere, you could have that text kind of thrown onto that surface and you can either cut into it, kind of like engraving it, or you can have it kind of project out a little bit where it's like you could feel the 3D texture over the top surface. There's a handful of other things here. There's also the hole tool. The hole tool, you can basically pick a certain point on a sketch and you can either have like some sort of a clearance hole that lets a screw just go all the way through it. You can have like a tapped hole or a threaded hole that the screw actually goes into and actually engages and turns into. and you can pick a variety of different kind of standard holes for standard screw dimensions. There's also this fillet tool. Like pretty much everybody who has a phone, which I'm pretty sure is everybody here, if you look at your phone, you have these kind of curved edges somewhere on the corners of your phone. That's a fillet. It's something to keep you from having kind of a sharp edge at the corner of something that can, cut things, scratch things. So you can either have a fillet, you can also have a chamfer, which is very similar, except rather than having some sort of a round corner, it's just some flat cutaway. It's a little bit easier to manufacture. There's also the shell tool. That one is very fancy. That one, so say you want to hollow out some part, but you don't want to go and add a whole bunch of features kind of following and tracing along some ugly geometry. As long as you get the basic outside geometry all solved, you can just hit that little shell tool, and you can use that to basically hollow everything out. We're actually going to use that later on with the cone. There's a handful of other things. There's like the thread tool that's like if you want to add in the threads for like a screw or a hole, you can do that. That also is built into this hole tool right here if you want when you do that later. There's some other things. And then over here we have some basic patterns that are very similar to the sketch versions also. So if you want some sort of a grid of features, you can do that. You can have a circular array of things. You can do a mirror. You can do all of that stuff. One thing that is also very helpful is these things called work features. Think of these basically as kind of imaginary geometry that it's not a part of the real part itself, but it's helpful for making some of the like reference geometry for it. Think of it kind of similar to, it's kind of like commenting code out a little bit. It helps make things a little bit easier to develop a little bit easier to understand. So we will use some of these later, and I'll visualize how to use that. So you can basically have these like reference planes that are, they're kind of like construction lines a little bit, or actually, better way to think about it. Who here has seen that one episode of SpongeBob where Squidward asks SpongeBob to draw a perfect sphere, and he goes through this whole process, makes a big fancy head, and then gets left with like a circle in the end? Has anybody seen that? Okay, I'm getting old, so yeah. But so if you can imagine, like when somebody's drawing like a figure of a person, the line work that they use to kind of represent some kind of a blob that's like their torso. Do you see that line in the end, the final product? Typically, no, unless the person's a little bigger. But typically, you won't see some of those lines. Those are those kind of early construction lines that help you get a general form for things, but they aren't a part of the final product. That's what these work features are. So you can have either planes, axes, points. So you can make planes from axes. You can make axes from points and stuff like that. We'll use a little bit of that later. One thing that you'll also see over time is that your browser on the left, as we add each feature in Sketch, is going to be added into that browser. So like this. Right now, on our traffic cone thing, it's mostly empty. We see this little sketch right here, but not too much else. There's a few other things, like there's this origin folder. We'll talk about that later. But if I go over to the existing traffic cone, it's got a little bit more things. So we've got one extrusion right here at the bottom. We've got some different things that, just each little added detail adds another item into this browser. And they're all in some sort of an order. If you think of it like, and the order of these does matter depending on how you want to make the thing. Kind of think of it how like anybody who has worked in like a Microsoft Word document, some big long report, you have a picture somewhere. You change the size of that picture from like 4 inches to 5 inches. Then it throws off the next 30 pages of your work. It messes up all the formatting. In CAD, you can do the same thing if you don't do things right. So whatever you do up here will affect everything that happens down below it. Everything from here down will affect everything else, but it won't affect all the things up above it. Just like a Word document, basically. let's see, if we go back to here. So you're going to have this whole browser. It'll populate over time. So everything is all in order, like what I mentioned earlier with ordered versus synchronous mode. Ordered is just way easier to deal with. One thing you can also do is if there is a certain thing that you want to kind of hide or disable, kind of similar to like commenting out code where it's like you're not quite deleting it, but you're not using it. You can do a similar thing in CAD where you can basically suppress a certain feature. So let's say I wanted to suppress this loft and everything down below it. What I could do is I could select that loft, and then I'm going to hit right click, and then it'll bring up this little window. I can hit suppress features, this little button right here, and then hit accept. So it'll pull up some errors sometimes because it's like, oh, you're trying to do something, but it doesn't exist. So what I've done is basically I have disabled everything for like that actual cone part and below on the timeline, to where now all I'm left with is this little part at the bottom. And then if I want, I can just undo that or unsuppress it, and then it just brings everything back. It's not quite deleted. You can see if I hit Control Y to redo it, you can see all of the features here. They're kind of crossed out, grayed out. So there is that. If we're back to here, this area we can actually play with materials and appearances. There's these little drop downs down here that we can play with, and I'll go over those a little bit later, but like they're pretty self-explanatory, but I'll go into those later. So now we've gone through the basics of the 3D part. So now let's actually do some 3D work. So now we're here. So if we have this square, does anybody have a guess as to what one of these tools we might want to use to turn that into kind of a thin little like square solid? Correct. So what we're going to do, we're going to hit extrude. And right here, it automatically identifies that, oh, we have some sort of a loop. That's because there's nothing else for it to select. But if you have some sketch that has like multiple regions that you could do different things with, it'll ask you to kind of click and choose which areas you want to do. So let's say we just want this thing to be 10 millimeters. We can do that and just hit enter. But let's go back and see what this tool is really about. So you can see there's some different options right here. There's this one part right here that's asking for a profile. I'm going to do one thing really quick. You do not have to do what I'm doing. I'm just doing something for a quick example really quick, just making two other regions really quick. If I were to go and make an extrusion, here it's asking me to select some profile. So you can see it's kind of highlighting over a certain square or a circle if I want. And I can click and choose whichever things I want. If I want to deselect something, I can just hold the shift button, and I can either click or unclick certain things. So I'm going to undo those really quick and go back to extrude. So that's that profiles area. And then also we can choose the direction of where this is actually extruding. So right now by default it's just going up. But if I wanted to have it go the other direction and go down, I can just hit this little flip tool and it'll bring it down the other direction. If I wanted to have this thing go kind of both directions kind of symmetrically, you can see I've got my sketch in the middle and I'm kind of extruding evenly from the top and the bottom. And let's make this number just a little bit bigger to be a little bit more visual or something. Or let's say something like that. So I can go from the top, the bottom, somewhere in the middle. Or if you want to go kind of asymmetrically, you can have kind of one side go up one way. So let's say I wanted the top to go up 200 or something, and then the bottom goes down that much. Very simple. I'm going to undo that. But so if I look at the measurements here, I think this is just 10 millimeters. So I'm just going to make this 10 millimeters thick, going from the bottom up to the top. Just something nice and simple. So now we have this, but if we look at our other traffic cone, you can see there's these little curves here in the corners. Let's try to round out these corners a little bit. So one way that we can do that is we can use this fillet tool right here. So here you can see you can just basically pick certain edges and you can add a curve to them. So what we're going to do is we're going to click that fillet tool, and then what it's going to do is that it's asking us to select some edges. So I'm going to kind of zoom in on this corner right here. So now we have a little preview of this right here. And what I can do is I can pick more than one edge at a time. So I've got that one right there. And let's make this a little bit bigger. So the measurement I've got here, it's radius of 100. So let's type in 100. So now you can see there's a little bit more of a curve there. And while I have this tool open, I can go and still modify like the angle that I'm viewing all this stuff at. So then I can kind of move things around and get to the certain areas that I want to pick. So let's go and pick the other 3 corners. So I've got this one right here, I've got this one right here, and then I have this one right here. So then now I have this preview of these 4 corners being rounded out. And if I want, I can still change the number of everything while I'm still editing it. So if I wanted it to be a circle, I could do that. If I wanted it to be like really, really tight, little round parts at the ends, I can do that. But I want this to be 100. So I'm just going to do that and then hit OK. Any questions with that at all? Pretty easy, right? It's just adding some little rounded corners, nothing too crazy. It's not rocket science, not yet. So, next we've got, now we have the base set up. Now let's try to figure out how we can do this kind of triangular round part right here. Now, there are multiple ways that this can be done. One way that I'm just going to kind of speed run one way just to give you a visual really quick, but then we're going to use a different tool instead in just a sec. One way that you could do it is you could use the revolve tool. So what we could do is I'm going to really quick turn some of these planes on really quick, these origin planes. And what you can do to view those if you want is you can hit this little folder right here called origin and then hit that little plus button to expand it. And you can select each of these just holding like the shift or the control button, and then right click on those and hit visibility. So then now I have these different planes open. And one way that I could make like a revolution, I could go, I'm going to make a sketch really quick, and I'm going to project this line right here, just saying that this line exists. That's where I'm starting a line from. And I'll kind of move up a little bit, some amount, and then something, let's say, and you do not have to do this. I'm just showing some quick visual of how this tool could work. So we could have some kind of a shape, something like this, or actually, I'll go slightly different. I'll go slightly in just a little bit and then draw in. So I could have something like this. I could add whatever dimensions I want. I'm not going to put anything since this is going to get deleted in a second anyway. I can give some kind of an angle measurement, something. I could hit finish sketch, and then I could hit this revolve tool. And then now what it's going to ask me to do is, so it identified this profile, but now it's asking me for an axis. I can pick whichever axis I want to use. So I'm going to select this middle line, and it gives a little profile of this kind of cone shape. So it's revolving this kind of truncated triangle shape around. And if I want, I can change the angle that it goes around. So if I wanted to go 180, I could do that. I can flip the direction. I can go side to side or asymmetric. It's very similar to how that one extrude tool works. So that's one way that the revolve tool can be used. So I'm going to delete everything really quick. I'm going to show you guys a little bit more interesting way that this can be done. So what we're going to do now is I'm going to use one of these little work features right here. I'm going to make a plane. And you can see there's a bunch of different options right here. Some of them are more complicated than others, but they're all very easy to use. What we're going to use this little offset this offset from plane tool right now. So I'm going to click that. And this is something that people can start following along with if you guys want. So now it's asking me to pick a surface to offset from. So I'm going to pick just this top surface right here. You can see it's kind of selecting it. So I'm going to click it. Then now it's asking me for a number. I'm going to put in a number that I want that plane to be separated from vertically. So I could do, let's say, I could do 100. And if I look from the side, you can kind of see it's making a line, or like it's a plane, but viewed from its side, it looks like a line that's 100 millimeters separated from the top surface. If I go to this drawing here, I can see that the number that I have is 750. And one thing I'll also mention, if you see this comma right here, that's not like a comma followed by 2 zeros. It's not that I'm like bad at typing in numbers. That is how the rest of the world refers to decimal points. They use commas instead of periods. So that is how they do things. So this is 750.00 millimeters. That's how like ISO standards work when typing in some of these numbers. So I want to type in 750 to give me basically the top plane where the top of this cone is going to end at. So I'm going to hit this little check mark. So now you can see I have this little plane right here. Very similar to how there's these planes down at the bottom that are our origin. We have this new one right now it's just called a work plane. It's just work plane 1 right now. So we have that. Next, what we can do is, I'm going to use this loft tool in a sec. And what I'm going to do for that, you can kind of tell from this tool a little bit, or like this little preview. Basically what it lets you do is that you can have kind of a series of loops or like a series of sketches, that what it'll do is that it'll take a loop from one and it'll drag it to the other. Or if you have a whole sequence of these things, you can make really fancy kind of biological looking shapes with some of this stuff. So what I'm going to do is I'm going to make kind of a big circle on the top of this, and then I'm going to make a smaller circle on this plane that's up above it. Then I'm going to use the loft tool to basically kind of stretch and combine these two circles together to kind of make this cone-like shape. So I'm going to go to the top of the surface here, this one down here, not the top one, and I'm going to make a circle. So now I'm kind of picking something at the origin. I'm just bringing a circle out. Then if I go to the dimensions right here, we've got 400 millimeters. So I'm just going to go and add a dimension really quick. Give a dimension to that circle. I'm going to type in 400. So let's see. So the origin, here, let me go out really quick. It should just be like whenever you make a sketch on the top of something, it should just make an origin point by itself. So like here, if I delete this sketch really quick and make a new one, and I'll turn the visibility on this other plane. So if I go and make a new sketch on this top surface right here, so you should see kind of a little dot in the middle.
So I need to undo all the planes.
You don't have to. That line should, or it might, like if you have the planes hidden, it might be just hidden underneath it, but your cursor should kind of snap to it. Like, here, let's see what you got. So,
do I need to select something?
So,
I don't see my origin. Do I need to undo it?
or, oh, you're not in a sketch, so you need to make a sketch first, and then pick that top surface.
That's what I was, do I need,
So then now you should have that dot.
So how do I know if I'm on the right plane?
So if I go, so I'm just Control-Zing back out. So all it was is, so I'm making a new sketch on top of this surface. So you can, if I zoom out.
So select that one. I
Yep.
just selected first.
Yep.
And it's on that one, even though
Yeah,
it's
so-
not a plane on top of it.
So if I go at a different angle, you can kind of see there's this yellow dot on the top middle of the sketch. So now, if I, yeah, so then you should be able to make a circle, and it should just kind of snap to that. Let's see. Let's see. All right. Does everybody have a circle drawn on the top surface of this little square? Yes. Are there any questions so far? Am I good to move forward? All right. So I'm going to move forward. So we have this circle now. We have 400 millimeter circle at the bottom. And now we're going to want to add a new sketch up here. So what we're going to do, we're going to go back, start a new sketch, and then we're going to select this plane. This is where that sketch is going to be. So it'll bring you back to this view, and it'll look like you're drawing kind of on the top here, but in reality, you're only drawing on this. You can kind of see where like your X, Y axes are at. You can see that we're drawing now on top, kind of on this plane right here. So now what we're going to do, so you can kind of see, you can kind of drag things to the side to give you a little bit better angle to look at things. But we're going to go and we're going to make a new circle. And you can kind of see we're going to snap to the little origin point in the middle. And then I think the next number we want is like 100 millimeters, I think. Something, yeah. So we want 100. So now we have that. Now I'm going to hit Finish Sketch. And these planes are kind of getting in a little bit of the way, so I'm going to turn those off, or at least turn the visibility for them off. So what I can do is I can select the things that I want on or off. So I can just use the shift, like hold the shift button to select multiple things, or you can do it one at a time. But I'm just going to select these three and then right click, then check this little visibility box right here just to turn it off. So then now if I go back to this home position, I can see there's this top plane that has this circle on it. Then I have this part down here, this solid feature that has a circle drawn on top of it. So it looks something like that. Does this make sense so far? Are there any questions? Yes.
Like the horizontal planes, because I got the, because you know the plane name.
Mm-hmm.
The ones you just disabled.
How do I, yeah. So those, if you go over to the left in the browser section, so if you open up that little folder just with the little plus or minus button there, so these top three items right here are those planes. If you just use either like, so you can just select those and you can toggle the visibility. You can just right click on them and choose whether they're visible or not. So you can select things in the browser to turn them on, or so like this one, let's turn this one on. You can turn it on or off here. You can also do it out here where you can just select the plane itself and then hit the visibility button. Pretty much all of the same options are the same depending on where you click it. So
I don't know why, but that's the XY plane that goes up and down. It only goes between the platform where we like extended it.
yeah, that's fine because right now what that's probably doing is that it's thinking, oh, this is the only area that actually has any solid mass to it. And so once we start adding more mass, it should update and it'll rescale itself to fit everything basically. All right. Am I good to move forward from here? Any last things? All right, I'm going to move forward. So now this is where it's going to get kind of magical. And it'll even get more magical later. So what we're going to do, actually, so we have this little reminder here to hit save. I'm going to do that since I haven't hit that in a while. So now we're going to use this little tool called the Loft tool. So I mentioned this a little bit earlier. So what we're going to do is we're going to click that. So here it brings up this little dialog, and basically what it's asking for is I want to basically select the certain things in a sequence that I want them to connect to each other in. So what I'm going to do, so it doesn't matter the order, so I'm going to pick like this bottom one right here. So it's going to pick one loop, and you can see it added sketch 3 right here. And then now it's going to ask for another thing. So I'm going to pick this other circle up here. So now it gives me a little preview, and it's basically taking whatever I have down there and stretching it up to the top. And it doesn't matter what kind of shape you are trying to have. It'll just calculate something that fits everything for you. So I'm going to hit OK on that, and it'll make this little I'm also going to turn this plane off really quick. Just select it, hit visibility. But now I have a basic cone shape. If I wanted to do something more complex, so you don't have to do this, I'm just showing a quick little demo. So like say I had some square, basically, something like this. I could go back and edit that feature to where, let's say I wanted to use the square instead. It'll calculate and then merge everything together where it's like, now I have this weird circular thing at the top that derives from a square at the bottom. I'm going to undo that though. So you can have whatever ugly, complicated thing and make this really fancy kind of swoop along if you want. All right. Am I good to move on from this point here? All right. So now if you look at this thing, you'll kind of notice it's a big solid block. And any person that has played with a traffic cone and tried to kick it hard enough knows that it is not a solid block. It's nice and squishy, it's hollow, really light. So we want to hollow this thing out somehow. There's a few different ways that we can do that. We can use the revolve tool to basically like make some sketch in the middle that like we do a revolved cut where rather than adding material, we're cutting away material. We can do something like that. We can do some fancy extrusion from the bottom where we go up and try to have it constrict at an angle weird. We can do something like that. There's a bunch of different ways that we can do that, but probably the simplest one is this magic little shell tool right here. And we'll do that in just a little bit. One thing we're going to do, though, is I'm going to add just a couple fillets on these corners really quick. Just before that, I'm getting ahead of myself slightly. So the radii for these fillets are just 25 millimeters. So what I'm going to do is I'm going to go up and hit the fillet tool. I'm going to select that. And then very similar to how we've rounded out these corners, we're going to select this edge and this edge. And then we're going to type in our number and give us 25. So then now we have these little curves. So we have this, and now we want to hollow it out. I'm going to actually hit save really quick. So what we're going to use the magic shell tool. So this button right here, what this does, this is really good for like, especially any kind of like cast parts, any kind of piece of plastic or rubber that might have a big hollowed out section. So we can basically use this tool, and what it's doing is it'll basically have the whole object ready to be hollowed out. I can type in a thickness that I want the walls to be. So for this, we want it to be 10 millimeters. And you can kind of see it's got a kind of highlighted red area on the inside that's giving us a slight preview of what this might look like. But you can see here it's asking us with this little red arrow right here, meaning we have to select something. It's asking us to remove a face. And by remove a face, that's meaning what is the face that basically gets kind of cut away that lets you look into the hollow part. So the part that we want to cut out is going to be this bottom face right here. You know how if you have a traffic cone, you can kind of look in the bottom and you can stick your hand in it, or you can put it on your head. You can do various stupid things late at night with your friends with them. So you can select this bottom face. Now it's going to cut it away, and you can kind of see now a little bit better on the inside that now it's hollowing out that whole section on the inside. It follows along with those little like rounded edges that we gave it a little bit ago. So we can do that. We can just hit OK. And then now you can see we have a hollow cone. You can do this for a whole bunch of things. Like you could make a fancy solid body of a car or like a toy car and then hollow it out if you want, and then you're left with these nice fancy kind of contoured like surfaces that are all thin. Yes, it would do that. Actually, let's see what that does really quick. Let's see. So if we modify this, it recognizes that as another face, but oftentimes like it'll basically ask for like kind of a chain of faces. So like say you had a cube. So if you imagined basically two faces that got taken away, that they were connected to each other, you'd be left with four faces that kind of make like the corner of a room, kind of with two walls taken out. Kind of, it would make something like that. So now we have this hollowed out. We basically, for the most part, have a little cone. If we want, we can add a little hole at the top here, just kind of cutting out. So what I'm going to do is I'm going to make a sketch at this top surface right here, this flat little surface, and I'm now going to add a circle just to the top of it. I'm going to go to the origin and then just make a little 50 millimeter diameter hole. Just nice and simple. I'm going to hit finish sketch. I'm going to use the extrude tool, but then now, rather than adding material like this, oftentimes it'll detect it automatically, but if you start changing the direction in the other way, you can see it changes the color, and now it's actually cutting away material. So here I can choose a distance that I want it to extrude things down, but if I say like I just want to have it cut through everything, I can hit this little button right here that says just through all, and what it'll do is that any material that it interacts with, it'll just go through it. You don't have to change the numbers or anything. So it'll just plow through everything. You could also, if I wanted to have it go to a certain plane rather than a certain distance, I could hit this 2 button and then I could pick a certain plane. So for example, I could pick the very bottom of the cone. So it'll drag it all the way down through there. So I could change the height of this no matter what, and it'll always go down to the very bottom of that face. I could also go to next, which basically just says anything that's in direct path of it, I'm going to cut it out. So a few different ways to do that, but we're just making a hole, not rocket science. So now we have this 3D model of a cone all designed and everything. But let's say we want to make it look pretty. Let's give it colors. Let's give it a sticker. Let's give it something or other. So if you remember a little bit earlier, there were a few buttons that we could play with that allow us to basically change the material and the appearance of something. There's these little drop downs that are at the top of the window. So the left one will apply a certain material, and with that, it'll also bring in a load of different material properties with it. So if you wanted to take this model and then do some sort of like finite element analysis on it, like if you wanted to see how much it like compresses if you apply 1,000 pounds on the top of this and just crush it. It applies stuff like that. It also has like thermal properties, all of that different stuff. So for this, let's just find like rubber is somewhere on here. And there's a whole, you can load in custom materials if you want to, but most of your common stuff is all in here. So I'm just going to say rubber. You don't have any. Oh, it may have been, when you installed Inventor, you may have unchecked one of these.
Everything because it took hours. It only took 1 hour, so maybe you did it not do right?
Yeah, because you have to make sure that like that you check like install such and such material library.
It said it was installing the material library, but I guess it didn't do it.
Possibly. Like if you just hit that little download application thing that it gave and just say install the material library instead of reinstalling Inventor or something.
Can I do just the library?
Yeah, you should be able to do that just fine. but for tonight's stuff, you won't really need that. Just as long as this one has some things, yeah. So this will at least give you the appearance of things. It'll at least make it look pretty. So you can see here, I changed the material of this to rubber, and by default, it made this kind of like this black rubber color. Let's try to spice it up a little bit. We can change the color. So if we want to change just purely the visual appearance of it, not necessarily the material, the second drop down over here has a lot more options for different colors. So for example, if we wanted this thing to look orange, bam, orange. Or does anybody have a color or a material? If we wanted, we can make this thing look like denim, I'm pretty sure. Like, yeah, you can have a denim cone if you wanted. I'm going to undo that, but you can do that if you want. So you can pick whatever cone or whatever color you want for the cone. And if you want to change more settings, there's also a few of these other things that you can kind of pick from, and that you can get into. If any of you have ever done other like kind of 3D modeling or graphic stuff, there's different textures that you can load in or make. I am not going to go through that though, because that is a whole other process that isn't really worth your time right now. So I'm going to hit save on that. So now we have a cone. So one thing that we can do if people prefer is, so on this cone right here, this little demo one, I have like a little, like I have an image kind of pressed against the side of it. Do you guys want to learn how to do that, or would you like me to skip that? Since that's kind of purely a cosmetic thing. You want to do it? All right. So this might be helpful, like if your 2-month team like has some mission patch that you guys put together for your project and you want to slap it on the side of your fancy final assembly, this is how you can do that. So what I'm going to do is I am going to make a new plane. I'm actually going to offset it from a plane. It doesn't matter which one. Let's just say this one. I'm just going to bring this out a little bit. Let's just say 100. Distance doesn't quite matter. What I'm going to do is I'm now going to make a sketch on that. Now what I'm going to do is, so I'm in my sketch. There's this little button up here called Insert Image. So you can put a whole bunch of different whatever the crap you want on here. So I'm going to pull up, I'm going to find just the Space Hardware Club logo. I have that somewhere on this computer. Or let's do this one. It looks a little bit different. So I can put that in here, and very similar to like how you do other things, you can do you can add dimensions for things. You can center it however. I'm not going to center it too fancily, but ideally at this point, you know how to just, dimension things, lay it out a little bit. So you can have this image, you can take it, you can move it around, you can rotate it if you want. What was that? Here, let's see what you got. So
that's a plane, right?
yeah, or well, so
I offset from the rectangle.
yeah. So what it did is that it's looking at specifically just that face right there. But like whatever you make, it goes past it. So like you can just make a sketch on it. So then you can do that, and you can, let's see, you can still draw anything you want up here. It's not limited to just that plane. Yes. So yeah, so I'm going to get to that in a sec. So first you'll have this sketch, and assuming you have a good enough image in it, so I'm going to hit finish sketch. So right now it's just out kind of floating in space. It doesn't look like anything real. And what we're going to want to do is there's a little button up here. It's called the decal tool. what that's going to do is, so we're going to, so right now it already selected the image because it notices that this is the only image available in this file, but then now it's going to ask us for which face we want to slap it onto. So we're going to pick this conical surface, and then I'm going to hit OK. Bam. Now it's slapped it on there. Now we have a thing. So you can, yeah, chances are if you have a really big thing, it's going to wrap around, it's going to look stupid. But on your, when you make your, like, your 2-month payloads or projects, whatever it is that you're making, you can have some flat surface that, like, you can slap a sticker on it, basically. You can have something like that if you want. So I'm going to turn this plane off, and we're just going to call that part done now for right now. Are there any final questions with that before moving to assemblies? So this little tool right here called decal. So if I click that, I can pick the image and then pick the surface that it's getting wrapped onto, and then it'll do that. So here I'll undo some things really quick so you can see. So I'll finish the sketch. So I'm going to go to decal. So it'll recognize this image by default, but if you have multiple things, you can pick whichever image, and then it's going to ask you to select a face. So then now I have that cone surface. I'm going to hit OK, and then now it projects it there. Yes. So like that. So I changed the shell thickness. Like if you did the, like, just default shell, it probably would have done like 1 millimeter if you just go to that shell feature. So does your thing look something like, does it look something like this, where it's got, you can kind of see something like this? Is that kind of what yours had? Where it's like, so all it is so what it is that what it did is, so what it's saying is that going throughout the entire part, everything is now 1 millimeter thick walls. But if I do 10, it'll recognize that this extrusion right here, when we made that, that was 10 millimeters already, so it's not going to go and cut into that at all. So, what was that? Oh, okay. So yeah, if it's thicker, then you'll want to just change it to whatever uniform thickness you want it to be. So we have that. All right. Any last questions before we move to assemblies? What was that? It will get slightly distorted at the edges, especially on like some weird. It'll look a little. It's best on like kind of flat-ish surfaces, but like in a sort of flat area. So like if it's small enough on a little curved surface like this, it'll look mostly fine. But yeah. All right. Next, we're going to go into assemblies. So this is where all of the parts that you spend time making are all going to get put together. This is where you're going to make your own little, basically, Lego building, basically, with all of your abominations of 3D printed parts and things that you're going to be making in a lab very, very late at night. So actually, before I show you these tools, let's make a new assembly really quick. So I'm going to hit save on this. And what I can show you is, it's like, let's just like very simply, we'll be able to basically make a stack of cones. So like what I have here, we can take multiple of these cones and then constrain them and kind of stack them together like this. So we're going to go to File, New, and then here we're going to pick standard millimeter.iam. This is an assembly type. One way to remember like how these different file types are, .ipt stands for inventor part. .iam is short for inventor assembly. A drawing down here, like this .idw, that's just inventor drawing. And this down here, this is a presentation, so inventor presentation. I'm not going to talk about that tonight, though. It isn't really relevant to the stuff you guys need right now. So we're going to make this standard millimeter.iam. And as we can expect, everything is empty. So we go to these tools, you'll see something that looks like this. So most of your activity, for the most part, is going to be done in the tools on the left right here. So this button right here called Place, this is where you're going to just place in your models that you've made or that you've downloaded from the internet or that you've gotten from your friend or one thing or another. There's also the Create tool. You can make completely new parts within an assembly, but I'm not going to go into that. That's a little bit more involved, but look up tutorials on how to do it, and it'll save you a bunch of time. There's also, like, you can move and rotate things. This constrain button or this joint button, constrain, what you can use for that is, say you have two parts that you have some flat faces that need to be contacting each other. You can use that constrain tool to basically have those two faces touching each other. Or you can have like a screw constrain into a hole. It centers on the central axis of that, and then you can shift it down to make the head of the screw go flat and flush against the top surface of whatever it is that it's going into. And then on the side, you also have different types of patterns, mirrors, and copies of things. Basically, just like the other stuff before. It's pretty self-explanatory. One thing that is also very nice, so Inventor and most other CAD programs have some equivalent to this also. So if we hit this little drop down by the Place button, there's this little thing right here that says Place from Content Center. If you don't want to go and model every single screw for your part or for your assembly, there's a whole database full of kind of existing designs and models for a whole bunch of different parts. Basically, any kind of commercial part that you can think of that's commonly used in engineering, so like different standard bearing types, different screws, different kinds of whatever. You can pick any one of these specific standard screws and you can load it in. So for example, let's just pick this one right now. So it's some type of screw, and then it's asking for, all right, what kind of thread description do we want? Basically, what's the diameter of the thing? Let's say an M5. And then it'll ask you for the length of that like extruded threaded area. And let's say we want a 20 millimeter long thing. We'll hit apply, and then bam, it makes a model for us. We do not have to CAD any of that. And then we can just throw that in, magic. We can do something like that if we want. We can copy and paste this a whole bunch of times if we want. I'm just going to undo that though, since we don't need that. So that content center thing will save you a lot of time. So like when you guys, pretty much every person's thing that you're working on in here, when you're putting it together, there's going to be some sort of screw, some sort of nut, some standard part that you're just, there's a box of them sitting in the lab somewhere that you're just kind of pulling from. Pretty much most of those, you can find them in here, or equivalent versions of them for your CAD model. The constrain tool that I mentioned earlier, what that is, so you'll use that tool and you'll pull up some box that looks like this that basically has you pick two different parts and surfaces or different features on those parts to combine them to give some sort of relationship to each other, whether they're touching or they're parallel or some sort of way to organize the position of them. So one thing that's also cool is sometimes you can just click the constrain tool, just pick two surfaces or parts of some features on a part, and it'll sometimes just identify what it is, or it'll predict what it is that you're trying to do, and it'll change a bunch of these settings here for you automatically, and it's pretty nice. Then also there's these work features here, very similar to earlier, where like if we need some sort of like kind of additional kind of construction geometry to reference when making some of these constraints, you can use them here as well to like kind of have some invisible like magic hands behind the curtain that are organizing how some of these things are oriented and laid out. One thing that I'm not going to go into tonight, but I highly recommend you check out later, there's these things called design accelerator tools. So in here, just the basic way when you open up an assembly file, you're going to see some tools up here, but then there's this little tab here called design. So these design accelerator tools, they are very, very powerful if you know how to use them right. If you want, you could basically make 1 or 2 custom parts yourself and place them in. And with the rest of these design accelerator tools, you could design an entire engine if you wanted. Every bolted connection, every like piece of framing, you can have entire like chain and sprocket systems, all of these different things. And it also does all of the analysis for you, where it's like, hey, you have some bearing with some diameter shaft and whatever loading, it's going to break. We recommend some other standard bolt, or not bolt, some bearing size that's a little bit better. Whole bunch of things. You can do the same thing with like gears, and it'll design the teeth for the gear for you. It is very, very powerful. Definitely check out some things for that. One thing that you guys might use at some point, if you decide to use any of these tools, this bolted connection tool right here, you can basically pick a sequence of parts that you want screwed together and say, all right, I want to screw right here. You pick some location, and then what you can do is it'll automatically pick some recommended fastener type for you, or like whatever compatible versions there are. You can add any kind of nut, washer, any kind of stuff you want, either in between parts or at the end of things. And what it'll do is it'll automatically make the holes for you in your 3D model. And in your assembly, if you're like, oh, you know what, actually maybe instead of a 3mm like screw, I want to use a 5mm one. Just change that option, and then it'll automatically update all of the files that are associated with that. So say you have like 20 different files or 20 different parts all kind of stacked together with some screwed connection. You can change that single bolted connection feature in an assembly, and rather than going and manually going in and changing the diameter of all these things, you just change that and it just goes boop, just automatically changes it for you. That will save you so much time. So definitely recommend looking into design accelerator tools on like just YouTube tutorials and stuff. So there's that. All right, so now let's actually assemble something. So I'm gonna hit this little button here and just go back to just normally placing something. So then now, if I go and find the traffic cone that we had, I'm gonna hit open, I'm gonna place this. Now we have that cone. And if we want, we can just put a whole bunch of cones if we wanted. So you can add as many as you want. Right now, just for simplicity, I'm just gonna have these 2 for right now. Now, one thing is that if I drag any of these, you can see I can just move this wherever I want. I want to constrain it somehow. I want to lock it in place. So what I'm going to do is I'm going to use some constraints to basically lock this thing around the origin. It's a good idea to have at least some like reasonable part that represents a good chunk of your geometry to be constrained around the origin. So this little origin tab here, I'm going to bring it up, and then you can see there's these planes right here. I can turn them on actually, just for simplicity. And so it looks a little weird right now, but it's just filling up the whole volume of things. So next, this first cone, I'm going to open up this little drop down, and then now we can actually see there's these planes right here. These are the same origin planes that were used in making this original cone file. So I'm going to hit right click and turn the visibility on that, and it'll also turn them on this one too. So I'm going to move that over to the side for right now. Actually, I'm going to undo that. That looked messy. So now what I'm going to do, so if I look from the side, I have this cone, and I can drag it around, however, and I can try to line these planes up kind of similarly, but it's never going to be completely exact. Kind of like how before, how we were trying to center that square when we were starting the cone. You can eyeball it as close as you want, but it'll never be exact. Before, when we were making that square, we just used some dimensions to lock everything in nice and perfectly. What we're going to use here is going to be constraints. So we're going to go out and we're going to use this tool right here. So what we're going to do is, so this little option right here, if you can kind of tell, you can got two planes that are facing each other, and they're going face to face with each other. Or you can have two parts where those faces then are both facing the same direction, but they're parallel with each other, or flush. So what we're going to do, actually, I'm going to make sure this is still recording. Okay, awesome, hasn't crashed. So what I'm going to do is I want to make sure that these planes, the relevant origin planes, are all facing the same direction. It's going to lock them all in place. So I'm just going to go, the order doesn't really matter. So I'm just going to hit this flush button right here. And then I'm just going to pick the origin planes for each of these. So then, let's see. So now we have that bottom one to add. And you'll also get a nice little kind of clicky sound probably, or like sounds like blocks kind of coming together. So now that cone is locked in place. I'm trying to move and drag it. It is locked in place. It is no longer moving. The second one, however, it is still free to move in one way or another.
Wait, were we only supposed to do the faces of one cone? Or were we supposed to do the X, Y's of one?
I just did it of one. The other one can still move around. So if you wanted to, or let's say, did you do all of them for all the cones?
Not yet. I tried to do 2 different cones and then I couldn't select it.
Okay. So, for example, if I had some constraints, so I'm gonna kind of do what you did. So I'll, just have something like that. Now it's locked in this plane. If I
So you just choose the plane that's the one it locks in? Like I can't choose.
So I did the 3 planes for that cone, and then I constrained them to the 3 origin planes of the overall assembly. But if you have something that, if you want to get rid of a constraint, what you can do, so for, let's see, so for this cone, I can hit this little drop down, and there's similar things for that first cone. At the bottom of the browser section for that cone, so
Like I've selected one plane and then I was like the other one.
so here, let's see what you got.
So I get to that plane, and then how do I select this one? Where do I click?
So let me see. So you might, let's see, have
Okay.
that one there, or so that one doesn't have any constraints yet. Let's see. So let's go constrain. Gonna make sure that option is clicked.
So I clicked that one, and then you click that one.
Yeah. So
Okay,
making
so
sure
I don't click. I was trying to click this plane, and it wouldn't let me.
Oh no, well, you can do.
So I'm supposed to click the plane I want it to line up with.
Yes, exactly.
Yeah, you do that.
So yeah, so I would do that with the other planes for just a single cone for right now. The other one you can leave just kind of free floating for right now, and I'll explain how to deal with it. So if you have a constraint that you want to either modify or delete or something, underneath each part, when you open up their little sections in the browser, you can find each little constraint that's active. So on this cone that we fully locked up, we have 3 constraints that are locking it in place. So we have this constraint right here, we have this one right here, and we have this one right here. So it's locked it in place in those 3 areas. It can no longer move. But this one right here, let's say we want to delete that, because this one, it's, you know, we accidentally added something, or we want to modify it. So if we wanted to just modify it, we can right-click on it and just hit Edit, and it'll bring up that dialog window again, and I can change things again. I can also offset things. So if I wanted things, like if I had these 2 planes, I wanted them to be a certain distance apart from each other, I could just type in a number here. I could type in 100, and it'll move it around one way. If I want to go the other direction, I can just hit negative, and then it's negative 100, and moves in the other direction. You can do something like that. I'm just hitting escape to get out of that. But if I want to delete it, I can just go over to the browser section right here, and then just right-click and hit delete, get rid of it, and then now it's free to move again outside of that plane. So, question? Did you, let's see. It might be, yeah, so what it was so the way that you're selecting things right now, you have it set so that you're trying to make things go face to face, but they need to be going the same direction. So the other, yeah, and then should be good now. Yep. All right, so what I'm going to do is I'm going to turn the origin planes off really quick, just so we can see things a little bit easier. So then now we're left with these 2 cones. We know this one right here, this one is our origin one. This one, I'm gonna just change the color. Let's turn this to denim. Everything, all right, so let's assume that denim is now the center of the universe of this assembly, basically. And now we want to stack this cone on top of it, basically. And kind of like before, we can kind of get things in kind of the general area, but it's never going to be exact. So how do we make sure that we don't have some kind of conflict where it's like, oh no, it's, you know, passing through it, it's just, you know, just something goofy that doesn't happen in the real world. So what we're going to do now is we're going to add some constraints to the 2 of these. So what we can do is I'm going to add another type of constraint where rather than having just 2 planes being coplanar with each other, I'm going to make, if you can kind of see these little circular sections that are cut out of the top, they will just be kind of lined up. So if I select this little circular surface on this inner part of the top of the cone, you can kind of see it pulls up a little vertical like phantom line that is kind of representing the axis. I can do the same thing on this other part right here. So then now those 2 axes are lined up directly on top of each other. And again, I can add some sort of offset if I want. I can type in a number and they'll be 50 millimeters off or 100 or something like that. But I want these to be concentric, so I'm just going to have that be 0. And I'm going to hit apply. So now what I could do, if I wanted, let's see, so I can still take this thing, I can still rotate it around. It's still free to move a little bit, but we are constrained. We're kind of locked vertically since we're sharing that same rotation axis there. So now let's try to keep us from being able to rotate. So there's a few different ways that I can do that. I can either take any of these kind of middle planes and line them up on top of each other, or I could use kind of the side planes right here and make them coplanar. I'm going to do a constraint with one of these middle planes. So I'm going to pick this plane, for example, and this plane. So then now they're lined up, basically, something like that. So I'm just going to hit apply. But then now, so I can't rotate it anymore. I can just slide it up and down. So then now, how would I take these and constrain them in just the right way to where I have it down and it contacts, but then doesn't just pass through it? So one little trick that you can do, so one thing actually, I'm going to turn these planes off really quick just to make visibility a little bit better. So I'm going to do that, and I'm going to minimize these tabs. So you might be trying to think, well, how do I try to look in here properly? One way that you can do that, you can kind of do what's called like a cutaway. So what you can do, you can go over to the View tab right here. There's this little button right here, and there's a little drop down. You can either do like a quarter section view, a half section view, 3/4, or a whole. I'm going to do a half section view. And what that'll do is that it's going to ask me to pick some plane that I want, and it'll kind of temporarily disable the front half of that part wherever I separated it at the plane. And I can move that plane a little bit one way or another if I want, kind of offset it one way. So let's just have it at 0, just right smack in the middle. So then now, what was that? So here, I'll go back really quick. So what we're gonna do, to go to that half section view, y'all, we can quiet down just a little bit. Guys, let's quiet down just a little bit, answering a question. So to get to that little half section view, I'm gonna go to this view tool right here. And then there's this little option right here. It has a little drop down. There's a few different options. We're going to choose the half section view. And so then now what that's doing is it's asking us to basically pick a plane that we want the cutaway to be based on. So I'm going to pick, on the origin, I'm going to pick one of these planes, and then let's just say that one. And I can drag it and move it around however I want. I can just type in an offset distance. I'm just going to pick 0, though, just something right smack in the middle. So now I am here. So I can go to the side and I can look and say, all right, so I can kind of drag things. I can get really, really close. But I can still kind of drag myself through this other part. So one way that you can make sure that it's directly touching in contact and not going through one or the other, we can then add a new constraint. We're going to add a tangent constraint. What we're going to do is we're going to basically have this surface right here, this nice conical surface, be basically in tangent with the conical surface of the inside. So we're going to have, I'm going to put this at a little bit of an angle so I can see a little bit better. So I'm going to pick this inside conical surface. It projects the rest of the way around with the part that is kind of cut away. So I'm going to pick that. And then on the other part, I'm going to pick that outer surface. And then now we can see, if I zoom in, we're directly lined up on each other just like that. They won't constrain. What kind of constraint are you wanting to do?
I don't even know. I have 2 cones right now, and I don't know what I did.
Okay. Let's see what we got here. So
one plane is constrained. I don't know which one. But something did something.
So I'm gonna minimize this. So we have this one has a whole bunch.
That's the origin one, I think.
Okay. So
and
then
the other
this
one I
one.
was trying to do it to the other cone.
So with this, I'm just gonna delete these, or actually I'm gonna delete that one. Let's see. Or actually, I'm gonna turn that one off and move that over. Or actually, here. So what it might be is that since they're so close on top of each other, okay, yeah, so that's what it was doing. It was,
how do I do the space thing? Like you have it, some space.
Yeah, let's see. Here, let's turn the visibility off on that. Oh, you got something. Oh, you got something way jacked up. Let's do that. Or actually, here, I'm gonna undo that motion. I'm gonna delete that. Move that off to the side. Turn that back on. So that now should be.
What was I supposed to constrain? The tops?
So what it was.
I did flush with the circle.
So I think you did just the circle. You want, or so with the circle, it's going to pick just that middle point. What you want is that whole axis. So you'll do the axis, and then from there, so if I go out, you should be able, yeah, so you should then have something like that.
Okay, so I did the point. So when I did constrain, at some point it flipped upside down.
Okay.
And I was like, okay.
So yeah, so with that, then it's basically like, if you imagine like two pencils that are like, you just have the points constrained, but you can still kind of wobble them around, however. It's kind of the equivalent of that it was doing. So then, yeah, so then you can you can line some planes up if you want to line everything up. But if you want to just skip to like having the things stack on top of each other, what you'll do is, did you see what I did with taking the taking like a section view of the thing? Did you see that part? So you'll go to View, and then you can just pick one of the planes. Yeah, you can pick any of them really, and then just hit the little check mark, and then you can go out. So now you can kind of see on the inside, and then you'll just make a tangent constraint between the inner and the outer surfaces of the cone. So now we have that. Okay. Are there any questions with any of this at all right now? Yeah, so here, I'll show how to do that again really quick. So here, I'll delete that and move this up. So one way that you can constrain this, so you're going to go hit the constrain tool, and then there's a few different types of constraints you can do here. So like this one is like, you'll have like flat faces going together. Here you can have like angles for things. What we're going to want is this tangent option right here. So this one that looks like a circle with a block to the right of it. And what we're going to do is there's two types of tangents that we can do. We can either have outside or inside tangents. We want an inside one since it's basically one thing inside of the other rather than two things kind of touching on the outsides. And so we're going to pick that. And then now what we're going to do, we're going to pick that inner surface of the cone on the outside. So you can kind of see it's giving a little preview of that inside surface. And then on the other cone, we're going to pick the outer part of that cone. So then we'll click that. So let's see. So here, see what apply does really quick. Yeah, you got it.
Okay.
So yeah, so if you want, you can still add another constraint where you just have, like, if you want to keep it from being able to rotate on the top, you can just add a constraint where some of the origin planes, you just constrain them so that they line up. Yeah, that's most of it. There's also, like, I won't go through it, but so if you are wanting to make drawings for things, so you guys will be asked to make drawings at some point, like in your PDR presentations. The way that you can do that, I'll just breeze through that really quick. Like you don't have to do it in real time. You can watch this recording later. You go to Make New, and then down here in any of these drawing things, I'm going to pick ISO.IDW. And then what that's going to do, pulls up a little sheet like this. And then if I want to have some views that I, have different views of a part or an assembly or something, and I want to add measurements to it, I can hit this little base button right here. And then I'm going to cancel. Or actually, I just realized I'm gonna hit save. Yes, actually. So that's one thing that's good. So like here, let me just do it's like cone assembly. So give it a sec. So if you get a window that says like save all dependent things, basically if you have a whole bunch of changes on a whole bunch of different parts, but if you just save the assembly, it'll give you the option of like, hey, do you want to also hit save for all of the other parts that have been modified too? And so you can check yes or no for any of those things.
It's not giving me no. It's like not letting me put it.
Well, at the very top, there should be something you say yes to.
So you can hit a base view, and you can pick some file that you want to make the drawing with. So let's say this right here. Let's pick a cone. You can pick whatever views you want. You can just kind of drag around. It'll make automatic kind of angled views for things. You can pick the scale of this. Let's say something like that. And then you can kind of drag things around however you want. You can choose whether things are colored or not. You can delete certain views. I'm going to click one thing really quick. So you can have, let's see, something like this. Pick some different options. I'm just rushing through this. You can look at the video later. So you can have stuff like this. And if you want to add notes to it, you can then go to the annotate section, go to dimension, and then you can just, all right, from here to here is some number. You can add additional notes if you want. You can pick some angle or something. You can do you can add whatever things you want. You can add additional lines for things. So like if you want to add a center line, or if you want to add center marks, stuff like that. Different things like that. There is an example of one of these like drawings. Let's see. So the file that was used to make this specific drawing is like the original like source file itself is on the Canvas class. So this SHC traffic cone.idw, that is the file that made this PDF. So you can kind of look and see how that's made. And one last thing, like when making some of this stuff, to import or export things. So to export something, so let's say we have a single traffic cone. Say we want to send that to a 3D printer or something. So what we'll do is we're going to go to export to CAD format, and then you can pick what kind of file type you're going to do. So like a 3D printer file is going to be an STL file. If you're wanting to just send the basic geometry to somebody so they can open it up in another program, you can use a step file. Step file is pretty much the standard file format if you're trying to go between multiple programs. There's a handful of other options that you can do. So there's that. One thing, if you export to an STL file, one thing that's important to do is, especially if you have a fresh installation that you haven't messed with any of these settings yet, by default, your STL export settings are going to be selected as this like BREP option, probably. What can happen with that is if you ever have a 3D printed part that has like circular or like curved geometry, what it can do is it's kind of a low resolution version. It turns into a bunch of polygons. So you can see basically it segments it into a whole bunch of lines rather than an actual circle. So you're going to want to change the resolution to be really high. You don't have to change any of these sliders. You can just select high right here, and it'll turn into a nice, pretty much continuous circle that'll look a lot better. So make sure you select that option there. And also pick the right units. Make sure everything is all right. So there's that. You can then just hit save. So there's that. And then if I wanted to, let's see. So if I have that, I can open this up in Cura. I can, or Cura is what I use as the slicer for the 3D printer I have in my apartment. I have a Ender 3 Max. Most of the printers that we have here that you'll be using for 2 month are going to be like, I think they're Prusa Mark IIs or Mark IIIs or something like that. Prusa has another slicer. So this is huge. I made it like a traffic cone. So you can see it's indeed a traffic cone. So I can take this thing, I can scale it, I can do whatever stuff I need. But yeah, you could try to 3D print this. Do not 3D print the traffic cone though. Please, please don't. So there's, yeah. There's stuff for laser cutting also. You can just look at this slide later if you're going to be doing laser cutting. And there will be a class on specifically laser cutting stuff, and this will be mentioned in there. Other exports, if you want properties like mass and stuff, or surface area for something, you go to File. There's this little option called iProperties right here. You'll go over to this Physical tab. I'm going to hit Update. Bam. We have, based on the material that we put in, the rubber. So this says it is 6.5 kilograms. Volume is a whole lot of cubic millimeters, but also a cubic millimeter basically hardly exists. So yeah, you can take that, convert that to whatever. This volume number can be very helpful when figuring out how much filament you need to 3D print a part. So you can do that. What other things we got? Conclusions. All right. Last stuff, basically. One guy that I recommend you check out if you're looking for tutorials. So this guy, I've watched his tutorials for like years, like back in the day when I was learning how to do stuff. Basically, you name it. So like, let's just say design accelerator tools or something. He'll probably have, bam, plenty of videos on stuff. So like, here's a half hour on how to use the bolted connection tool if you want to watch it. But he's a funny guy from the UK, actually has a personality, has some tone in his voice. Like if you're watching a tutorial, you're probably not going to fall asleep. So goes through how to do all the things and explains stuff. He's pretty good. Like if people need like CAD tutorials for Inventor, this is who I recommend they check out. So there's that. And obviously there are loads more tools and things that can be used throughout all of this stuff. Like didn't even touch, or was it? Didn't even touch any of this stuff up here, or, you know, there's so many different things. Like just go play around, see what you can make. There's a lot of different things that you can do. Are there any questions, anything at all? Y'all ready to go home, ready to go to sleep? All right, cool. Well, thank you all for coming. Thanks for sticking around. I can answer more stuff if you want here, but other than that, I will see y'all later. Have you restarted the computer since you installed it? I would try that. Because it is a huge program, and so like a restart might just be good. Refresh everything. Yeah. You got something?
Yes, sure.
All right, Ben. There's a
Don't die.
yeah.
So I use SolidWorks. I have for my entire high school career. I was the CAD monkey for my first team. So as I'm transitioning to Inventor, can I just email you at random times asking you questions, or is there someone else?
Sure. Yeah, you can do that. You can send me a Discord message or something. Yeah. Like also like first thing I would say, Google it first. there will be something out there. And then if there's something that even after like Googling it or trying to find some tutorial, there's still you don't know what to do, then yeah, message me. Because yeah, like if I was answering every single question from everybody, I would die. Like so yeah.
But you wouldn't rather me bug someone else. I'm okay to
Like right, so basically I'm the main CAD guru within the club, like or like at least one of them. So and at least when it comes to Inventor stuff, I'm the main Inventor guy. So like Inventor or like Autodesk was one of the sponsors that like literally sent me to do like Russian international CAD competitions. Like it's so goofy, but like it was a lot of fun. So yeah, like Inventor is pretty sweet. The one thing I will say is I do like some of the simulation side of SolidWorks better. Like you can do some simulation stuff with Inventor, but at least I think there's a little bit more flexibility with what you can do with SolidWorks in terms of simulation stuff. But for anything that you're doing in 2 month, like you don't need anything too crazy. It's not like you're doing like you don't have to do CFD analysis on any of this stuff. Like and there is CFD stuff for Inventor, but
I was looking forward to that.
yeah, like which challenge are you on?
C.
See, okay, yeah, like one thing you might be able to do, or well, actually, because I think you guys are going to end up using a program called like XFLR5, something like that. I might have the acronym wrong, but it's something like that. It's like airfoil simulation stuff, like calculating like coefficient of lift and drag and different airfoil types and stuff like that. There will be a whole class on that, I think. I don't know which one specifically, but it's something. If for some reason it's not taught this year, there is still a recording from the one last year. So, all right.
Have fun sleeping.
Oh yeah, you too.
This is kind of a non-CAD related question, but since you've worked on so many projects, I figured you might have an answer.
Okay.
Out of the companies that you've worked with and that might be at the career fair tomorrow, which ones would you say work more with international connections or like partner with other international companies or programs?
Like here, actually, really quick. Let me stop the recording really quick. Let's see. Goodbye, recording land.